All right, so as I said, I'm going to work based on the topics, I'm going to work the questions from starting with the 2021 January paper. And I'm going to start with organic chemistry. And so organic chemistry, is 2 questions from organic chemistry. Remember to mute your mic as you enter. And if you're just coming in, the session is being recorded. All right, so I'm going to start with question number 3, which is on organic chemistry, January 2021 paper.
Oh, hold up. Leave this. Hold up.
Please check your mic and mute it.
Please mute your mics as you enter the meeting. Mute your mics as you enter. Thank you.
I'll do the funny.
Recording in
I don't know if in the funny.
Yeah, Chanel.
Students, remember to mute your mics. All right, so the question basically asks us to define structural isomerism, and then it is asking us to draw the structure for 2-methyl butane and an isomer of pentane, C5H12. So we're going to define structural isomerism, which we know. So structural isomerism, I'm going to answer 3A.
Participants. Vacancy. Let me something.
Students, it's very simple. Just check that your mic is muted. All right, so structural isomerism is just the occurrence of compounds. They have the same molecular formula, but different structural formula. All right. Then I'm going to draw the structure for 2-methyl butane. So 2-methyl butane, first I'm going to draw 4 carbon atoms because it says butane, so I must draw 4 carbon atoms. It says 2-methyl, so on carbon 2, I must have a methyl group. If I'm counting from this direction, this is carbon 2. If I'm starting from this direction, this is carbon 2. I'm going to start from here. So this will become carbon 2. So on carbon 2, I must have a methyl group. And the methyl group is a CH3 group, a carbon with 3 hydrogens. I'm just muting some mics.
Some TV news.
So just press mute all.
All right, so this is the structure for 2-methyl butane.
Kiran?
Students, mute boy.
Mr. Ear,
Yes,
is it possible to start from the other end as well?
in terms of what?
Like in terms of direction, can't you go from the carbon down the other side, counting from that side as well?
Gemini said it. So you can, if you want to count from this end, this is carbon 2. But if you count from this end, this is carbon 2. So you can choose. All right.
Okay.
So because right. So I chose to start from this end. All right. Then no, the next
Excuse me.
question. Yes. Go ahead.
Isn't the molecular formula of methane CH4?
That is correct.
So why are there 3 hydrogens bonded to carbon?
It's not methane. This is a substituent group. It's methyl, methyl. So it's not methane, it's methyl. So CH3, a carbon, right here. This is it, CH3, it's methyl. So you have a CH3 group attached to the butane chain, CH3. All right, when you have a CH3 group, it's called methyl. Understood?
Yes, thank you.
All right.
Sir,
Yes?
the branch of chain is necessary to the bottom instead of the top.
Sure, it can go above or below because it is still attached to carbon number 2. So whether you put it above or below, it is still attached to carbon number 2. So it doesn't matter if it's above or below. All right, so the next question, it says,
Sir.
Yes?
You can put the other one beside it too. Still 2.
Yes, it will still be 2. Because it would be 1, 2. All right, so it says draw and name one other structural isomer of C5H12. So this is one isomer of C5H12. C5H12 does 3 isomers. So even though it asks for 1, I'm going to draw the next 2. So remember, isomers, they're the same. Yes, this is pentane, so pentane is also 1. So remember, isomers, they have the same molecular formula, but different structural formula. So this one, it is C5H12. C5H12. This is also C5H12, but it is not the same structure because this is pentane.
Somebody could have tell me say it start.
So remember how we get isomers quickly. If you're asked to draw isomers, right? C5H12, you have 5 carbon atoms. Just draw the 5 carbon atoms in a straight line. What you would do next, you would remove a carbon from the end, and so you would have 4 carbons left, and you put it on a carbon within the chain. That is how you would get the 2-methyl butane. To get the next isomer, you remove a next carbon from the chain. If you remove a next carbon, you have 1, 2, 3 carbons remaining. All right? So we have 3 carbons, which is forming the main chain. Remember, if you remove a carbon, it must go on the carbon atom within the chain. All right? So if we have 3 carbons here, which carbon atom is actually within the chain, not at the end? So these 2 carbons will be the end carbons, right? So only this one is within the chain. That means these 2 that we have removed from the main chain can only go on the carbon in the middle. All right, both of them must be attached to it. So you have to put 1 above and 1 below. All right, then you put on your hydrogens.
Sorry.
Can anybody name? Oh, go ahead with your
So basically, we can sub anything on the main chain except for the end.
Right. Because what would happen if you put it back at the end of the chain? If you put it at the end, you're going to get a compound that you already have. All right. But again, this is just revision. I can't go into much details. All right. So if you want, there are videos on the channel if you have the time to go and look in details. All right. So can anybody tell me the name of this structure here? I think I saw someone typed it.
2-dimethyl propane.
That is correct. So the main chain, it has 3 carbons, right? So once you see 3 carbons, we know that that is propane. I'm going to erase pentane so that I can write the name. So we have 3 carbons, that makes it propane. Then now we have branches. We have a methyl group here, and we have 1 on top. So we have 2 methyl groups. So it's not just propane, it is methyl propane. But when you have 2 or more of the same substituent groups, you add a prefix. So the prefix for 2 is di. So it is dimethyl propane. You also have to tell where the groups are present. So you have the main chain is 3 carbon atoms. Both of these groups are attached to the second carbon atom. So both of them are on carbon 2, and that is why I would say 2, 2 dash dimethyl propane. So C5H12, it has a total of 3 isomers: pentane, 2-methyl butane, and 2,2-dimethyl propane. Right? So this question was an isomerism. So those will be the 3 isomers for C5H12.
Can you just repeat that one?
Sir,
Yes, go ahead.
sir, after the meeting is finished, sir, will we have access to the recording?
Yes, it's posted on YouTube at, just put it here, just Google, just YouTube. Mr. Here's chemistry lecture series. All right. As soon as the class is finished, right, I will post it there.
Excuse me, sir.
Yes, go ahead.
So when they ask you for the isomers, you can just break off one of the carbons with the hydrogen on it and then branch it.
Right, but when you break it off, just ensure you do not put it at the end. All right?
Creating one at the middle.
The carbon within the chain, not at the end. If you put it at the end, you are going to get back the compound that you are starting with. All right, so just remember, take off one from the end, but then do not put it back at the other end. Just put it on a carbon within the chain, and you will be fine.
Thank you.
Excuse me, could you explain once more why you have 2 twos at the beginning?
So you have to tell where the methyl groups are located. Both of them are on the second carbon, right?
Right.
Yes, so given the position for each of them. So 2 methyl, 2 methyl. That is why you have 2, 2.
Okay, yeah, thank you.
All right, so I'm going to, yes?
And why do you call it dimethyl?
So when you have 2 of this same substituents, we use a prefix. So if you did have 2 chloro groups, we would say dichloro. If it's 3, you say tri, and if it's 4, you will say tetra. So when it's 2 of the same groups, you use di. If it's 3, you use tri, and if it's 4, it's tetra. So tetrachloromethane, 4 chloro groups. Trichloro, 3 chloro groups. And 2 chloro groups, dichloro. Right?
Sorry again, one more question. Let's say that that thing was bigger, right? And you have one branch at the second carbon, and let's say you have another branch at the third carbon, assuming that there's another carbon over the other side.
If you have a methyl group here and here,
right,
it would be 2, 3.
Oh,
because,
all right.
Yeah, one would be on carbon 2, and the next one would be on carbon 3. So you would write 2, 3.
So is it that you list the top one, then the bottom one, or just the left, then the right?
No, it's the position. So you would write 2, then 3.
Yeah, but let's say,
you see whether it's above or below,
yeah,
it doesn't matter because it is attached to the same carbon atom.
Oh, yeah.
So this is carbon 2, this is carbon 3. So you would write 2, then 3.
Yeah.
Right? Whether it's above or below, it's still carbon 2. Because the line is showing you that this is attached to this carbon. So when you put it above or below, it is the same carbon atom. All right? We have a lot to
Sir, wait, me have one question before you wrap up.
Last question.
Wait, no? So if you're coming from left to right, you have to follow through from left to right. You can't go like from left to right and then from right to left.
No, one direction.
Okay.
Yeah, man.
Sir, me did I write a bet, you know?
You have to catch it when we post it here because we have a lot to get through. All right, so when it's posted, you can just check it back. But we have to move on. All right, so the next question now, it says ethanol undergoes various reactions. Depending on the reagents and conditions of the reaction, products with different functional groups can be formed. So it says, what is the functional group of ethanol? So it gave us the molecular formula for ethanol, which is C2H5OH, right? What is the functional group of
alcohol?
OH. Alcohol.
Right. Well, alcohol is the whole molecular series. Functional group is the
OH.
group, and it's called hydroxyl group. All right. Right. So the hydroxyl group, OH, that is the functional group. Alcohol, that is the whole molecular series. So if they ask you for the functional group, don't say alcohol. That is the whole molecular series. So the whole molecular series of this compound is alcohol. All right. But the functional group is the hydroxyl group. All right. There's a difference. Is anyone
Sir, can you also give the functional group for the other one, like the alkenes and the alkanes?
We will get to that. All right. I just want to complete this particular question first. All right.
Okay.
Okay. All right, so now, for organic chemistry, you have to know the reactions of the alkanes, alkenes, alcohols, carboxylic acids, esters, and polymerization, right? So they can ask you on any one of them. So in this particular question, all right, which is dealing with the reaction of ethanol, we have a table, all right? So we have the reagent, conditions, and products. The reagent for the first one, so let's just move quickly. All right. Oh, it's just two columns. So what they want us to do is complete the table. So we're going to complete this table by inserting the reaction conditions and drawing the structure of the product. So we're going to complete the table. So remember, this is a table showing the reactions of alcohols. All right, they did not give us the reagent for this one. They asked us for the condition, and the product is the alkene. So what would you react an alcohol with to get an alkene? Does anybody know?
Sir.
Yes.
Concentrated sulfuric acid.
Water.
Water is the reagent. All right. You need sulfuric acid as well, but the reagent is water. The concentrated sulfuric acid and the temperature of 170 degrees Celsius are the conditions. The reagent, they did not ask for it, but the reagent would be water. All right, so if you have ethanol, all right. Sorry. It's not, no, there's no water. I'm thinking about hydration. It's dehydration. All right, that is why they blocked out the reagent part. Because this reaction here, it's dehydration of the alcohol. Right, so if you dehydrate the alcohol, it means you are removing a molecule of water. To do that, you are going to remove OH from one of the carbons and hydrogen from the next carbon. And if you notice, you end up with C2H4, but you won't have a single bond, you will end up with a double bond. All right? So the product, the structure of the alkene is ethene. So this is a dehydration reaction. Alcohol, if you have an alcohol and it is converted to the alkene, that is dehydration. They could have asked for the name of the reaction in the next settings. They did not hear, but it's dehydration. These are the conditions. This is the product. So whichever alcohol you start out with, you will get the corresponding alkene. So if you add propene, if you add propanol, you will get propene. Butanol, butene. So whichever alcohol you have, you will get the corresponding alkene. So here, up here, you would have drawn your alkene. This here is not required, it's for explanation purposes. All you would have done is know that it's a dehydration reaction. So if you have ethanol, the product is ethene. All right, and that's it. For this one now, we are reacting ethanol with ethanoic acid. Which reaction is this? Where we react alcohols with carboxylic acids.
Acid hydrolysis.
That's a reaction of ester.
Esterification.
Esterification, right? So we are forming the ester. So if you have carboxylic acid and ethanol, the condition, we're going to use concentrated sulfuric acid again and heat. All right. So let me just go over the reaction for esterification so that you can see how we get the product or the structure of the product. So we have ethanoic acid. There's no hydrogen here because carbon form 4 bonds always. So you cannot put a hydrogen here because this is 2 bond, 3, 4. So you have the carboxylic acid and you have the alcohol, which is ethanol. All right. So in esterification, you are going to remove the OH group. You're going to remove the OH group from the acid and the hydrogen from the alcohol. So what we're doing, we're joining up the carboxylic acid to the alcohol. How we're going to do that? we're going to remove the OH group from the acid and the hydrogen from the alcohol. So if we remove the OH group from the acid and we remove the hydrogen from the alcohol, right? Then now we can connect the carbon to the oxygen, and that is how we get the ester. So remember, you have the carboxylic acid with the OH group. You have the alcohol as well with OH. But we are removing the OH from the acid and the hydrogen from the alcohol. And then we're connecting the carbon to the oxygen. That is your ester.
Excuse me, sir.
Yeah, go ahead.
Sir, could you possibly name the compounds as you go along, because I have a problem with naming them?
Sure.
Okay.
All right, so everybody understand how we get the ester here?
Yes, sir.
Yes, sir.
Not really.
All you're doing, so the reaction is between the carboxylic acid and the alcohol. To get the ester, just remove the OH from the acid, remove the hydrogen from the alcohol. And then
From water.
you're going to get the water as well. All right? But that is
Plus
all.
water.
So all you do to get the ester, remove the OH from the acid, then the hydrogen, and just connect the two of them. No, you will not draw this long line, right? So let me just put it back, OH plus this. The product, so let's start back. So you will have the carbon, 2 carbons for the acid, double bond O, single bond O, and put on your hydrogens. All right, that's your ester. So did we get this? Remove the OH, remove the hydrogen, and we connect the carbon to the oxygen. That is esterification. All right, so that is how we end up with the ester. Of course, the OH and the H, that is a molecule of water, we would also get. So if you do an esterification reaction, you will get the ester as well as the water molecule.
Sir, is this a condensation reaction?
That is correct. You're joining up 2 compounds by removing a molecule of water.
Sure. So when you add water, you separate them.
Hydrolysis. Was that what you're asking? No. Continue.
So let's say when you add water, you separate them in most cases. Separate the bond.
Yes, so if you join 2 compounds by removing a molecule of water, if you add back the water, you can separate them. And that's called hydrolysis. All right? Yeah. So that is how we would get the ester.
Excuse me, sir.
Naming the, go ahead.
How do you differentiate alkene and alkane?
In terms of experiment?
Yes, overall.
Can I use them?
If it's by looking at this structure, I mean?
Yes, sir.
Alkene have a double bond and alkene have a single bond.
That is correct. So,
Sir, I can use the oxidizing or reducing agent to test that.
Or bromine water. But I'm going to work a question on that as well. All right? So,
Okay,
right, so this is the ester. I'm going to show you how to name the ester now. So, all right, here what? Let me just run through organic chem quickly because it seems like most persons forget. All right, so I'm going to go through our organic chem quickly, just a quick recap, and then we return to the
You're
question.
actually gonna stop text coming down, son.
All right, so let's just do a quick recap. Yes?
You can focus on the reaction when you go back over.
Sure.
Yes, sir, and naming them.
All right, so for alkanes, right? There are 3 reactions for alkanes. All right, so alkanes, functional group.
Double bond. No, single bond.
Right. So these are the basic things you must know them. Functional group of alkane, carbon to carbon, single bond. The general formula.
CnH2n plus 2.
Right.
Yes, star man.
H2n plus 2. All right. I'm going to put 2 compounds on the board and we name them. All right. All right, so generally, right, when you're naming an organic compound, the name has 2 parts. All right. The first part of the name, it tells you how many carbon atoms are present. The second part of the name, it tells you the functional group. All right. The first part of the name tells you how many carbons. So I'm using this as example. C3. Whichever compound has 3 carbons, the first part of the name is pro.
So that's propane, right?
And because it's an alkane, once you hear it will end in A. So once you hear propane, it tells you it is an alkane.
Alkane.
Right. Once you hear pro, it tells you it has 3 carbons.
3 carbons.
If you hear propene,
Alkene.
It's an alkene.
Alkene, yeah.
So when you hear ane, it's an alkane. Once you hear ene, it's an alkene. Once you hear anal, so like methanol, propanol, ethanol,
Alcohol.
it's an alcohol.
Alcohol, yeah.
Right. Once you hear anoic, it's a
Alkanoic
carbonic acid, right? So the ending of the name tells you the homologous series to which the compound belongs. The number of carbon atoms that is given by the first part of the name.
Sir, could you repeat, please?
Could mute your mic and let Mr. Ear explain what he's doing. You will learn. So you can't be talking while he's talking.
Right, so again, the basic form of the name, it has 2 parts. The first part gives you, it tells you how many carbon atoms are present. So if you hear pro, it's 3 carbons. If you hear meth, so once you hear meth, that's 1 carbon. So meth is 1 carbon. F is 2 carbon. Pro
3 carbons.
And bute
is 4.
4 carbons.
So
C4.
the first part of the name, it tells you the amount of carbons. Then the second part of the name now tells you the homologous series. So once you hear methane, the ane tells you it's an alkane. If you hear methane, it tells you it's an alkene, but it also tells you that it is an alkene with how many carbons?
With 2 carbons. 2 carbon atoms. Yeah.
Right. If you hear butanol, then it's an alcohol with how many carbons?
4 carbons.
4 carbons, right.
The general formula for that CnH2n plus 1 OH.
Right. And if you hear ethanoic acid, we know it's a carboxylic acid with how many carbon atoms?
Two. Sir,
Right.
Mr.
Yes.
Ear, the student
Yes.
who is talking, the young man who is constantly talking, could you please mute your mic? The others cannot hear. So if Mr. Ear is talking and you are talking, we won't learn anything. So please
Exactly.
mute your mics.
I'm sick.
Excuse me, sir, before you start,
Yes.
is it only organic chemistry you'll be doing tonight?
Well, I'm trying to move quickly, so I want to do other topics as well.
Such
all
as
right?
moles, that would
And
be good.
electrolysis and others. All right, so let
Sir,
us do
question.
yes. Quickly.
Right. So there's a general formula as CnH2n subtract 1. What is the name of that? I don't remember. I think it have a the functional group is a triple bond. It says
We don't do triple bond here. For CSEC. Yeah. Man. Right. So let us name two compounds now, right? So we don't do alkynes, we do alkenes. All right. So I'm going to put a compound and then pour it now. If you get a compound with just carbon and hydrogen, and by the way, this formula here, where you just have the number of each atoms, that's the molecular formula. So C3H8, when you just get the atom and the amount, that's the molecular formula. If you're asked to draw the displayed formula or the structural formula, this is the one that you draw. So this is the displayed formula, where you draw out each atom and show how they are bonded to each other. All right, so C3H8, this is the molecular formula. Go ahead quickly.
So do they also ask us for the empirical formula as well?
No. All right, so you must know the draw.
Sir?
Yes?
Sorry, if you draw the thing in a different format, like the one where you have like the troughs and crests, is that okay?
Please repeat.
If you draw it like the skeletal structure, is that okay?
No. For CSEC, we don't do skeletal structure. This is what you must do. All right?
Okay.
Yeah, so we don't do skeletal structure for CSEC. All right, this is the one we do. Right, so if you get this compound to name, right, all it has is carbon and hydrogen. So you count up the amount of carbons, it's 3 carbons. So we know it is pro. The only functional group present here is carbon to carbon, single bond. So you know it's an alkane. So this compound
Excuse me,
is
sir.
very easy to name. It's propane.
Sorry, sir. Carla Taylor, please turn off your camera.
Quickly, with the question. Oh. All right, so this would be propane. All right, now I'm going to erase a hydrogen, and I'm going to put on chlorine on it. All right. You count the amount of carbon atoms. So it's 3 carbons. So it is still propane. All right?
Sir, that would be chloro.
So 3 carbons, it is propane. However, this time it is not just carbon and hydrogen. So it's not
Sir,
just
that would be chloropropane.
right. So now here we have Cl on it. So you have to name it. This is not Cl. So in organic chemistry, Cl is chloro, not chlorine. When you are naming it on a structure, it is chloro. So it is still propane, because of the 3 carbon atoms. But this time, it's not just hydrogen, we have a Cl group. And so now we have to say chloropropane. All right, that's how we get chloropropane. The final part of it now, we have 3 carbon atoms. You have to tell which one it is attached to. If you count from this direction here, it is attached to the first carbon. So the chlorine
would be 1 chloropropane.
1 chloropropane.
All right. Now, if the chlorine atom was here, it is still attached to the first carbon. So it is still 1 chloropropane.
Excuse me, sir.
Just a second. If the chlorine was up here, it is still 1 chloropropane because in each instant, it is attached to this very same carbon, which is the first carbon. So whether it is above, below, or to the left, it is still attached to the first carbon, so it is 1 chloropropane. The position of it, whether it's above, below, or to the left, doesn't affect it. It is still attached to the carbon number 1. So it's a 1. So 2 things. The count of the amount of carbons, that tells you the parent name. So it is propane. Then you look if you have anything other than hydrogen attached to the carbons. In this case, we have a chlorine atom. So it becomes chloropropane. And finally, we have to look at which carbon atom it is attached to. It is attached to the first carbon, so it's 1 chloropropane.
Sir, question, instead of having the 1 there, could just have monochloropropane, right?
No, put the number.
No, mono is 1 chlorine carbon atom.
In the name, this number is for the position. You have to tell the position of the chlorine. All right? So that is why we have the 1 here. Good?
Sir, for the exam, will they ask us to like draw more than 4 chlorine atoms? Like, can it go up to 8?
No, it won't happen.
So if you had the chlorine like in between the carbon atoms, that's still eligible?
Please repeat.
If you had the chlorine, let's say, right, in between the carbon atoms, is that still eligible?
You mean like a chlorine here?
Yeah.
No, that doesn't.
That doesn't exist.
There's no, that's not a chain.
Oh, someone was asking in the chat now, so I asked.
No. So it's always the carbon atoms that are attached to each other within the chain. All right. Next now, what if you have 2 chlorine atoms? All right. If you have 2 chlorine atoms, same 3 carbons, so it is propane.
So that would be 1, 2 chloropropane.
Yes, yes.
Yes, sir.
When you have 2 of the same substituent, we apply a prefix. So because you have 2 chlorine atoms, it becomes dichloro. All right. So just remember.
Sir, that would be 1, 2 dichloropropane.
Yes, sir, since it's on 2 different carbons.
Right.
Isomers.
So can it be on the same carbon?
It can be on the same carbon as well. But I'm just going through all these scenarios first. All right. So 2 chlorine atoms, you have to use the prefix di. Di because it's 2 of them. All right. After that now, again, you have to tell where the 2 of them are. Starting from here again, this would be the first carbon, this would be the second carbon. So one of them is on the first carbon, I'm putting a comma. The next one is on the second carbon. Then I put a dash. You put a dash between the number and the word, but you use a comma to separate the numbers. So it is 1, 2 dichloro propane.
Sir, you put.
One,
Go ahead.
go ahead.
Sir, you put dichlor because it's two branches from the same group, right? What if you had like chloro and OH?
I'm going to do these scenarios. All right, so I'm just going through them. So this is where
Excuse me.
go ahead. Quickly.
Excuse me, if you were to have
Look, hold on, I'm going through it.
if you were to write that in a formula.
I'm going to show you all the possibilities, all right? So I'm just starting out with this and show you all the possibilities that will come, all right? So I'm here now. The next scenario, we have a next scenario, all right?
Question.
Where I have the lines, those are hydrogens. So again, the first thing I will do, count the amount of carbon atoms. 4 carbon atoms, that's butane. Okay?
Excuse me, sir.
Yes.
Does it depend on where you come from when you're finding how many chlorophyll is on the thing? What do you call that?
When you
Right at the top one that you
Sir.
listed.
Sir, question.
Yes.
If there was 2 chlorine atoms on 1 carbon,
remember
what would you
we did
say
that
it
one
was?
Remember, just like with the methane, where we say 2,2-dimethyl, it would be 1,1-dichloro. Both of them are on carbon 1, so you would have to say 1,1. You have to give the position of the 2 of them.
So that I was talking about, sir. You start from the left or the right. Like it depends.
Excuse me, if you were to write that out in formula form, what would it look like?
Repeat?
If you were to write that in a formula formation, what would it look like?
You mean like condensed formula?
Yeah, like how you'll have
I'm sure that, all right? I'm going to show you, I'm recapping, so the quicker we can move, the better, right? So I'm just going through all these scenarios for the name, and then we'll look at the condensed structure. All right, so quickly. If you have the same substituent, you apply a prefix.
Sir, a question about what you're doing here.
All right, quickly, last question.
The one thingy that says dichloropane, I think it would be 1, then 2, because it states that there are 2 chlorine.
No. The di, listen carefully. The di tells you the amount of chlorine present. The number tells you the position. In this case, both chlorine are attached to carbon number 1. If you put 1, 2, it is telling you that one of the chlorine is attached to carbon 1, and the next chlorine is attached to carbon 2. That is not the case here. Both of them are attached to carbon number 1. That is why you have to put 1, 1 to let us know that both of them are attached to carbon number 1. The die tells you the amount, the number tells you the position. Is that clear?
Yes, sir.
All right. Down here now.
Sure, do that again.
The number
Sure.
tells you the position.
Sure.
All right. So, guys, this has to be a revision. We have a lot to get through. I cannot explain this in details. Remember that the exam is in the morning, and we don't want to spend an hour teaching in alkanes. All right. There are videos.
What's the name of that though, sir?
Yes, we have to
What's
move
the name
on.
of it though?
What's the name of?
What's the name of it though?
Of
Like
what?
you have the bromine and they have the chloride. You have bromide and carbon too, and then you have the chloride.
Right. So let me explain this example now. So you count up the amount of carbons. It's 4 of them. Once it's 4, we know that it is butane. Remember now, it's not just hydrogen, so you cannot leave it as butane. We have bromo and we have chloro. When you have 2 different substituents, list them in alphabetical order. So bromo must come before chloro. All right, so that's the next rule. 2 different substituents, it is bromo, then chloro. All right. This here, bromo is on carbon 2, right? Because you count from the end, that gives the substituent the lower number. If you count from this direction, bromine is on carbon 2, chlorine is on carbon 4. 4 and 2 is 6, all right? However, if you count from this end, chlorine is on carbon 1, bromine is on carbon 3, all right? 3 and 1, that is 4. So we have to count from this end. All right, so 1 chloro and 3 bromo. All right, listen, with naming compounds at this point, you won't get more than 2 marks for naming a compound. All right, so I'm actually going to move on to reactions of alkenes. The reactions is where the marks are. So you have to know the reactions. To name a compound, it's 1 mark. All right, so we cannot spend any more time on it. As we go along, if the name comes up, we look back at it, all right? But we have to move on to the reactions of alkanes, alkenes, alcohols quickly. All right, so I'm going to shift from naming the compounds and drawing them because these are just 1 mark or a 2 mark. We have to look at the reactions. So I'm actually going to move to the reactions of alkenes. So for the last thing, if you have 2 different substituent groups, you list them in alphabetical order. So the bromo comes before chloro. And we count in the direction that gives them the lowest number possible. If we count in this direction, it would have been 2, 4, right? If we count in this direction, it's 1, 3. So we choose 1, 3 versus 2, 4. All right? So I'm going to move on to the reactions. All right, so alkanes, 3 reactions. The easiest one is combustion. All right, you're going to react the alkane with oxygen. You're going to get carbon dioxide and water. All right, so combustion, you're just reacting the alkane with oxygen to give you carbon dioxide and water. This reaction happens if it's in excess oxygen. So if you have enough oxygen, you are going to get carbon dioxide and water. If the oxygen is not enough, you are going to get carbon monoxide. All right, so if the oxygen is not enough, you get carbon monoxide. But if you have enough oxygen, you will get carbon dioxide. All right, so unless the question says, just a second, unless the question says you don't have it, if you don't have sufficient oxygen, if it does not say that, this is the equation to write. If it is insufficient, then you just put CO. All right, but for combustion, all you have to do, write the alkane and the oxygen, you always get carbon dioxide and water. That is it for combustion. All right, this is it, nothing more, just an equation. The alkane plus oxygen give a carbon dioxide and water.
So
You can-
we have to balance it.
Yes, ma'am, we have to. So I'm going to do that next. Someone other question? Emil?
Sir,
Yes.
if it's not sufficient, the oxygen over the left side is supposed to change.
No, man. As in terms of the balance
O2 part, though. It's supposed to be the same. Oh.
Yeah, man, right. It is going to be C3H8 plus O2.
Oh.
Yeah, man. It's just that the supply of it is not enough for this to go to CO2. But as long as it is enough, you will get CO2. All right. Next, we're going to balance this equation. When we're going to balance this equation, we're going to do carbon first, then hydrogen, and then oxygen. All right, so quickly, this is C3H8. So we have 3 carbon here. That means I must have 3 carbons here as well. So that balances my carbon. Next, I am going to balance my hydrogen. I have 8 hydrogen here. That means I must have 8 here. 2 hydrogens are already in the compound. So all I need to do is put a 4 in front, because 4 times 2, that gives me 8.
Sir, I'm not seeing anything on the screen. I'm not seeing the screen.
Exit and come back. Or something. I'm not sure why I'm not seeing it. All right, so right. So we have 3 carbons here, so I have to put a 3 in front of CO2. We only have 1 carbon in CO2, 3 times 1 carbon, that is 3. So 3 carbons, 3 carbons here. Next, we have 8 hydrogen in the hydrocarbon. We only have 2 hydrogens here. So to balance the equation, I have to put 4. 4 twos is 8. All right. Next, we have to balance oxygen. We have 2 oxygen here, but on this side, 3 twos, that's 6 oxygen. 4 ones, that's 4 oxygen. So we
10
have a
oxygen.
total of
10 oxygen.
on this side. So 2 times 5
5, yes, sir.
gives you 10. All right. I'm going to do a next one quickly.
Sir.
Yes.
One time, the alkane thing with that a while ago, the bromine and the chlorine, and the normally is the alkene, the double bond is broken and it react and then react with the bromine and the chlorine to get that
No.
by additional reaction.
No, that would be 2 separate, 2 separate reactions. Just a second. Right, so 4 carbons here. So we need 4 carbons here. We have 10 hydrogen here. 2 hydrogen is in water. 2 times 5, that is 10. 4 twos, 8 oxygen. 5 ones, 5 oxygen. 8 and 5 is 13. Whenever you get an odd number, if you get an odd number, all you need to do, put it over 2. When it comes to oxygen, if you get an odd number, just put it over 2. All right? It will balance out. 13 over 2 is 6.5. 6.5 times 2 is 13. All right? So any odd number you get for oxygen, just come here and put it over 2 and it's balanced. All right. If you get 5 oxygen, 9 oxygen, 11 oxygen, come over here, put 11 over 2, 5 over 2, 7 over 2. All right. And that's it. Yes.
So like you times the number of CO2 by the number of H of hydrogen, like 4 times 4 times 2, then 5 plus 5.
All right, so oxygen is in 2 different compounds. So we have to check how much oxygen is in CO2. So 2 oxygen is present in 1 mole of CO2. But we have 4. So 2 times 4, 8. And then we have 1 atom of oxygen in water. But we have 5 moles of it. So 1 times 5, that is 5. So we have 8 oxygen from CO2 and 5 oxygen from H2O. So the total amount of oxygen on this side is 8 plus 5, which is 13.
Okay.
Yeah, man. All right, so we have to move on to the next reaction of alkane, which is cracking.
Sir,
Yes.
sir, why do you have a 13 over 2 in front of the oxygen? Sir, I thought you couldn't put fraction.
When you get an, you can use fraction for this reaction. So when you get an odd number, instead of multiplying the entire equation by 2, all you need to do is put the odd number over 2, and you're good. Is that clear?
Yes, sir.
All right. 13 over 2 is 6.5.
Sir.
6.5 times 2 is 13. Yes?
Sir, we have to balance the equation, sir.
Yes.
This one, yes, it's balanced. Because you have 13 oxygen here. 13 over 2 is, to get 13, you need 6.5. You cannot put a decimal, so you would use it as a fraction. 6.5. 6.5 as an improper fraction is 13 over 2. Hence, I said, whenever you get an odd number, just put it over 2. So 13 over 2. All right? And you're good to go. Cracking.
Excuse me, sir.
Yes?
Where the 4 is beside the CO2, does the 4 not change the amount of oxygen as well?
Which 4? This 4?
Like O2, O2 right there, so.
Yes, that's 4, 8 plus 5, 8. 4 times 2 is 8.
4 2s, that is why we have the 8 here. 4 2s, 8 oxygen. 5 1s, 5 oxygen. 8 plus 5 is 13. Guys. All right, guys, we're not going well with our organic chemistry, and this is the entire section. But I think we should move to, honestly, we should do some next topic. This is not, because our organic chemistry is a big topic.
Yes, sir.
Our organic chemistry is a whole section. And if you're struggling from alkane, it's best we, so topics like electrolysis, that's a topic, and we can catch that.
Yes, sir. Can we do?
Chemistry.
Can we do?
Go through some more concepts, please.
Yes, I'm going to do those now, because
Yes, sir. More concepts, sir. And then electrolysis.
our organic chemistry, that's an entire section, and we need a lot of studying and practice. So we're not going to catch it tonight.
Sir, I want to get an introduction of organic chemistry.
Is it me?
Yes, sir. I need it too.
All right, if you have the time, the YouTube, we have done, I have done classes on our organic chemistry, recorded and posted from the scratch. So if you have the time, sometime tonight and you want the intro, you can.
No, sir, because it said on the list that we only get an introduction. So is it only an introduction we're getting?
No, it doesn't say intro alone.
Actually, sir, it does.
It's
the name of YouTube channel?
Carbons as
We're
well.
getting more.
If you look at them, you actually have reactions. It's not just intro. Look back at the topic.
Okay.
Let
Just
me read
if you do the
it.
next topic.
Yeah, well, remember now, organic chemistry is an entire section of the syllabus, section B. So there's no way you would just get intro. You have intro and the reactions. But
Sir, are you going to
yes,
get the hydrocarbon as well and reaction of carbon compounds?
when they say reactions of carbon compounds, they are referring to alkanes, alkenes, alcohols, carboxylic acid, esters. Those are a lot of reactions to go through. And we're already struggling on combustion and cracking. And we just have tonight to do as much. All right. So after the class end, I will try and work some questions and post it. All right. But I have to move to our next topic because this is an intersection and some of you don't understand it. All right. We can get through electrolysis as a topic, but organic chem is a whole section. All right. So let me do electrolysis. All right. So question is coming on electrolysis. Electrolysis is a more narrow topic. It's not a section of the syllabus. It's a topic. All right. So for electrolysis, we have to know how to define it, right? So let us just start with a definition. Remember to mute a minute. All right, so it's simply the decomposition of an electrolyte when an electric current passes through the electrolyte. What we want to focus on first is the term electrolyte. All right, so we're focusing on the term electrolyte. So your electrolyte, it contains mobile ions. So if our electrolyte contains mobile ions, we need to know which substances can be used as an electrolyte and which cannot. Ionic compounds are used as electrolytes. Ionic compounds, they can be in the solid state, they can be dissolved, or they can be molten. Ionic compounds can act as an electrolyte if it is molten or in solution. All right. So your electrolyte, it must contain mobile ions. The only compound that we know that have ions are your ionic compounds, right? but they cannot be in the solid state, and I will put the reason shortly. So just remember, as your electrolyte, it must be an ionic compound. Also, the ionic compound, it must be molten or in solution.
Sir, in solution means it's aqueous.
Right. So it's aqueous, right? All right, so your electrolyte, right? Once it is in solution, it must be able to either do two things: accept an electron or give up an electron. The ionic compound, when it is molten or in solution, it can do that. But in the solid state, the ions are not free to move because they are still held in the ionic bond that was formed. Right? So if the ions are not free to move, they cannot move about, collect the electron or move to the anode to give up an electron. So if you are asked, for example, all right, I'm going to do it after. All right. So the focus here is on the electrolyte, and we just established that it must contain mobile ions. Therefore, ionic compounds is used as the electrolyte. Covalent compounds are not electrolytes. So just make a note of that. Ionic compounds, when molten or in solution, that is your electrolyte. Covalent compounds are not electrolytes.
Excuse me, sir.
Yes.
One time the ionic compounds are molten, right?
Right.
Is it called aqueous or is it or what is it named?
No.
I want to know the formula.
Aqueous means you dissolve the
Have
compound,
water in there, sir.
right, in a solvent, right? Molten, you literally, just like you would put butter on a hot surface or in a pot and turn on the flame and it melts from solid to liquid. That's molten. Solution, it means you dissolve it. All right? All right.
So, sir, what is going to be the formula for molten? Like when you write it for molten?
Same thing. All you would put is the state symbol. The state symbol would be liquid. But if it's the solution, it would be aqueous.
All right.
Right. So, for example, NaCl, if you see liquid, it means it is molten. And if it's in solution, then it would be aqueous. All right. So it is the state symbol that you use to indicate it. All right. Acids. So your ionic compounds, acids and alkalis. those are electrolytes as well. Because we know that what acids will donate a proton, right? So let me just show you why. Is everybody of this already up here?
Yes.
If you have a solution of sodium hydroxide, for example, if you have a solution of sodium hydroxide, what you actually have, you have sodium ions and hydroxide ions. So even though we write it as NaOH aqueous, what it really means, because when you dissolve something, they break up. So the sodium ion is separated from the hydroxide ion. And so now your electrolyte, it has what? Positive ions and negative ions that are free to move. Your acid, for example, hydrochloric acid, right? When it is in solution, you will have the hydrogen ion and you will have the
chlorine ion.
So that is why acids are also electrolytes. All right.
Sir, can you repeat that, please?
Acids are
The acid
electrolytes.
and bases, sir.
Right. So
Are
ionic compounds,
conductors.
the acids and the alkalis, they are electrolytes. No, you have strong electrolytes and you have weak electrolytes. So your strong electrolyte, they dissociate completely. So you will have a lot of ions present in your solution. So it is a strong acid, a strong bases, they dissociate completely or ionize completely in solution, which means that you will have a lot of ions present. All right. So these are your strong electrolytes. And weak acids will be your weak electrolyte.
Sir.
Yes.
Weak electrolyte can be water too.
Right. No, for weak acid, any organic acid is a weak acid. So any carboxylic acid is a weak acid. So like, for example, ethanoic acid. All right, so for electrolysis, at least know the definition, then know some examples of strong and weak electrolyte, know why ionic compounds. I'm going to post it, and can someone just type the name of the channel? Someone was asking.
Yeah,
Right, so we know how to define electrolysis. We know that ionic compounds can conduct it when molten or in solution. And we also know why it cannot conduct it when it is a solid. All right. Covalent compounds, they don't dissolve in solution to form ions. All right. So covalent compounds, they don't produce ions. So they cannot be electrolytes. All right. Next, I'm going to draw the diagram now and explain what happens in electrolysis.
What, on YouTube?
So you probably have to go dry too.
You can be out to dry. It's simple. Yeah, man. Adjust this. All right. So for
So that's
electrolysis,
that's electrolytic cell, right?
right. So what do we need? We need a solution that contains mobile ions. Or electrolyte, right?
Electrolyte, yes.
Sir,
Right.
sir,
Yes.
you know, got anode and the cathode.
Yeah, man, I'm going to leave there, man, but I'm just starting out, right? So we just catch everything one time. So first, we must have a solution with mobile ions. So that
Sir,
will
can
be
you use
our-
sodium hydroxide, sir? Sodium hydroxide.
All right, you want to use, I was going with Molten.
Sir, use sodium hydroxide.
You can use as well, so any of them. All right, so if you want to use acid, your alkali or your ionic compound, that can be used, all right? So after we have our solution, so inside of it, we would have sodium ions and chloride ions, right? So that is our solution. Now, we need something, right, that can remove electrons from this solution, all right? That part of our terminal where electrons are removed is the anode, all right? And the electrons are returned at the
cathode.
Right. So when you set up the cell, right, electrons are going to be flowing from the anode
To the cathode.
come to the cathode. All right. So electrons are flowing from the anode to the cathode. This right here, if it's graphite, so we can use as our electrode, you could use metal, right? So you can use reactive metals, or you can use inert electrodes, for example, graphite, all right?
Wait, sir?
Yes.
Sir, what's the difference between the inert and the active electrode?
As it says active, it is going to actually take part. So inert, it is not taking part. If you did a reaction with, if you set up a cell with, say, aluminum, metal, or copper, they will actually be taking part in the reaction. When I do the purification of copper, you will see what I mean, all right? I'm going to use that part and explain it, all right? Or show you more likely, all right? So the electrodes are what? Removes electrons and return it. So we have the electrolyte, we have our electrodes. And of course, we will have the power supply, all right? Whether it's a battery or an equipment, we call it a power supply, source of electricity, right? So this is the diagram. What are we going to ask for? So over here we have the anode, over here we have the cathode. A reaction is going to be taking place at the anode. A reaction is going to be taking place at the cathode. Why does the reaction occur? So remember, electrons will be leaving the anode. That means the electrons are going to be used up. Right?
Sir,
Yes?
what if you use sodium hydroxide? Would it be the same?
Yes, it will be the same. So remember, your electrolyte, it just contains mobile ions. I'm going to show you what happened with the ions, all right? So the setup is the same. That is why I was saying all you need is a solution with mobile ions. It doesn't matter which ions I use, all right? As long as it has ions, we're good, all right? So there's acid, salt, alkaline, it's good. So electrons will be leaving here. That means over here will be the electrode here will be depleted of its electron. And over this side, remember the electrons are coming here, right? So over here, it will be depleted of electrons. And over here, it will have a surplus. Good? So when that happens now, the positive ions.
You can repeat that with the surplus, please.
Right, so remember now, the electrons are leaving the anode and they are going around to the cathode. So they are accumulating at the cathode. So the electrons are leaving the anode and accumulating at the cathode.
Sir, is the positive ion, is the negative ion that attract to the anode, right?
Yes. So the positive ion, so remember now, the cathode, let me just a second. So the electrons flow around, accumulate on the cathode, so it develops a negative charge because the electrons are accumulating on it. And as a result, the positive ions in your electrolyte will accumulate around the cathode. And because the electrons are leaving the anode, it will develop the positive charge, and so the negative ions will be attracted to the anode. All right? So what happens when the negative ions are attracted to the anode and the positive ions are attracted to the cathode? I'm going to use two equations to explain it. All right? So let me put it in.
Sir,
Yes?
sir, don't erase it as yet.
No, I'm just going to erase the word graphite electrode.
Sir, 1 second, please. You said that diagram. What's the name of the diagram, please?
The electrolytic cell. So if they are to draw the
The what?
cell.
Can you repeat, please?
Yeah.
All right, thank you very much.
So oxidation and reduction is going to take place. Just a second.
Sir.
Oxidation and yes.
Sir, you know, them usually have some chemical equation they could write it. Like
that's
so they might ask you chemical.
Yeah, that are the
that's what I'm
reduction
about.
and the oxidation. That's
Like the reduction.
Brother, when you can't just shut up at that, the man I go do, and just shut up now.
All right, so oxidation and reduction is going to take place. So remember now, oxidation is the loss
I see what's wrong. I figured out what's wrong. Okay, so it is
So oxidation is the loss of electrons. Reduction is the gain of electrons. Right? So the negative ions, we have the chloride ion. You have the chloride ion and you have the sodium ion. The chloride ion is negative. It can afford to give up an electron. The sodium ion is positive. It will want to gain electron. So your negative ion is going to be oxidized. Your positive ion is going to be reduced. So at the anode, let's start with the anode. At the anode, your negative ions always goes to the anode because the anode is positive. So the chloride ion is going to go to the anode. It is going there. Let me just finish and then ask, all right? So the chloride ion is going to go to the anode to give up the electron. That extra electron, which is the reason why it has a negative charge, is going to come to the anode. So let me just draw it. So Cl minus, it is going to come to the anode and give that electron to the anode, and so the process can continue. So your negative ions come to the anode and give up the negative charge, which is the electron. All right? And so they are oxidized. So the chloride ion, if it gives up this charge, it does not have any charge remaining. So the chloride ion comes to the anode, gives up the negative charge, and so it has no charge. All right?
Sir.
Just let me finish, please. I saw answer. All right, so the chloride ion gives up the negative charge. So this is the negative charge. The electron is the negative charge. It is given up. Now, chlorine, it does not exist as an atom. It exists as a diatomic molecule. So you cannot have Cl. You must have Cl2. All right? So because chlorine does not exist as an atom, you have to write it as a diatomic molecule, all right, which is Cl2. Now, if you have Cl2 here, it means that you cannot have one chloride ion. You will have to have two chloride ion to get a molecule of chlorine. And if you have two chloride ions, each of them would give up an electron. And so you must also have two electrons. So it takes two chloride ions to form a molecule of chlorine by giving up a total of two electrons. So this is what will happen at the anode. And for the anode, for csec, the typical compound that you get, they tend to have a halogen. So you could get chlorine, bromine, or iodine. The reaction is the same, both of, so fluorine, chlorine, bromine, iodine, they are all in group 7. They are all diatomic molecules. Hence, the equation will be the same. It will be 2, if it was bromine, it will be 2 bromine ions to form Br2 by giving up 2 electrons. So this equation, it doesn't change. All right, the person that wanted to ask the question, you can go ahead if you still want to.
Never mind, got to. But thank you though.
All right. Yes.
There's only like chlorine with the anode.
The negative ion. So whichever So when you have your electrolyte, whichever negative ion is present, it will go to the anode. So for our example here, we were using molten sodium chloride. So the negative ion is the chloride ion. And so it would go to your anode.
Sir, for the negative electrons, we can write it that way, all of them that way, with the 2 CLR, 2 bromine negative?
Yes.
Okay.
For the group 7, chlorine, bromine, iodine, yes, it's this. All right. So for the anode, that is what happens. This is oxidation. All right. Let me put the reduction down here. So just remember, for oxidation, the electrons are on the right side of the arrow. So for oxidation, electrons go on the right side. For oxidation, electron will be on the left-hand side. So what is happening at the cathode? Remember, at the anode, the negative ion will come and give up the negative charge, all right? And so it gets oxidized. At the cathode, the positive ion is going to come and it is going to pick up a negative charge. So when it picks up the negative charge, it is going to cancel the positive charge on it. And so it is left with no charge.
So it becomes neutral.
Right. Oh, by the way, so when we say it is the decomposition of the electrolyte, so the electrolyte, it was what? It contains sodium ions and chloride ions, right? The chloride ions will be converted to chlorine gas, and the sodium ion will be converted to the atom. So that is the decomposition. All right. So the cathode, we have the sodium ion, right? And tomorrow's exam, so look, you see whatever the charge that is on the positive ion, that is the amount of electron it is going to gain. So sodium, it only has a positive charge, so it is only going to gain 1 electron. This 1 electron is going to cancel the positive charge, and so you end up with sodium. All right. Now remember, it is molten sodium chloride. So the sodium ion here, you should put a liquid. Even when you form this, it is still in the molten state. All right. So the electrolyte I was using is molten sodium chloride. So the state symbol should be liquid. So this is what happens at the cathode. Your positive ion goes there, picks up an electron, and forms the atom. Your negative ion goes to the cathode, gives up the negative charge to form an atom. However, bear in mind, your chlorine, that is a diatomic molecule, it does not exist as an atom. That means you must be getting Cl2 and not Cl. All right? So as soon as you finish here, we want to work some more equations and look at the aqueous one as well. All right? So as soon as you are ready to move on, just let me know.
You can move on.
All right, good. All right. So, but what I'm going to do, right? I am giving you the electrolyte, and then we're going to write the equation for the reaction occurring at the anode and the cathode. So if we have molten lead bromide, the positive ion. So if you know about ionic compound, right? We always put the positive ions first, then the negative ion. So the lead is the positive ion, and lead has a charge of 2+. So the ions present, if you have molten lead bromide, the ions present would be the lead ion and the bromide ion. So at the cathode, you would have the positive ion, which is the lead ion. I remember I said, whatever the charge and the ion, that is the amount of electron it would want to gain. So if it is Pb2+, in order to cancel 2 positive charges, we are going to need 2 negative charges. So if these 2 negative charge cancel these 2 positive charge, you are left with the lead atom. All right. The anode, you have the bromide ion. Remember, bromide ion is in group 7. Therefore, it is a diatomic molecule. So you will get Br2. So you will go from bromide ion to Br2.
Yeah, I got the two different.
So, right, if you have Br2 here, you are going to need 2 bromide ions. If you have 2 bromide ions, each of them will give up an electron. So that will be a total of 2 electrons. All right. So just make a note. These equations are never going to change. So Br minus Cl minus I minus.
If it was lead bromide, molten lead bromide, it would be bromine that's giving off.
That is correct.
Okay.
Right? So if you are to write an equation involving bromine, chlorine, or iodine, these are the equations. They are never going to change. So once bromide ion is the electrolyte, this is the equation. If chloride ion is the electrolyte, this is the equation. If this is the iodide, if iodide ion is the electrolyte, this is the equation. It is not going to change. All right. And all of this will take place at the anode.
Sir.
Yes.
Sir.
Yeah. Go ahead.
I'm not hearing you.
I'm not sure why. Because others are. I'm not sure.
Yes,
Sir?
Yes.
You can show like how you get like the deposits, them, how you know what is the deposits?
How I know what is going to be deposited?
Yes, sir.
So if this reaction, if this is the reaction, right? So it's the metals that are going to form deposits, and it would be in an aqueous solution. So like you would get lead solid or that or so forth, those would be deposited. But your negative ions, they are going to produce a gas. So you would see bubbles being produced.
Okay, sir. Thanks.
All right, does everybody have this? We can move on.
No, sir. I'm not seeing it clearly.
Or you just make a note of where and you just watch it after we upload. All right, because time is going. So when I upload it, all right.
Or you can send me back the name of the link that you'll be uploading it to.
Someone just type it.
And it's on YouTube, right?
Right. Someone just type it.
Okay, thanks.
Yeah. All right, so this was with molten electrolyte. Remember, it can be a solution. All right, so if it's a solution, the solution, it can be diluted or it can be concentrated. So it can be a dilute solution or it can be a concentrated solution. Now, previously, if you have an ionic compound and you melt it, all you will have is the ions that make up the compound. However, if you dissolve it in water, what is going to happen? So I'm using back sodium chloride. So you will have the ions from the compound. So for example, sodium and the chloride ion. But from water, you will have hydrogen ion and you will have the hydroxide ion. So once it's a solution, you no longer just have the ions of the salt, but you have hydrogen ion and hydroxide ion from water. Whether it's diluted or concentrated, it doesn't matter, it's a solution. So these ions will be present. Now, you will need to know, all right, so positive ions, as we know, will migrate to the cathode. Negative ions will migrate to the anode. But we have to determine which of the positive ions will actually take part in the reaction. And to do that, we look at the electrochemical series. Now, the good thing is we are comparing the ions to hydrogen. So whichever ion is above hydrogen will not take part. Now, for hydrogen, below hydrogen, you only have copper and silver. All right? So don't try and study the ions above hydrogen. Just remember that below hydrogen is copper and silver. All right? So how we're going to choose? The ion that takes part is the one that is further down in the electrochemical series. So comparing sodium to hydrogen, hydrogen is below sodium, so hydrogen is going to take part, not sodium. All right? So for the positive ions, it's the one that is further down in the electrochemical series that will take part. And as I said, the only two below hydrogen that we would use is copper and silver. All right? So in this case, hydrogen is going to take part. Whether it's diluted solution or concentrated, the same rule applies for the positive ion. All right? Now for the negative ion, just remember this, if it's diluted, your OH will take part. If it's concentrated, the ion of the salt will take part. So for the negative ion, if it's a dilute solution, the hydroxide ion is going to take part. If it's concentrated, the negative ion of the salt is going to take part. But for the positive ion, all we're looking at is the position in the electrochemical series. So if we were doing the electrolysis of dilute sodium chloride, the reaction occurring at the anode it's the hydroxide ion that will be taking part. When the hydroxide ion takes part, you will get water and oxygen. All right. I'm just going to balance this equation. All right. Water, oxygen gas, and you will use a total of 4 electrons. So for the hydroxide ion, whenever you use the hydroxide ion, this is the equation. You use 4 hydroxide ions, you will get 2 moles of water, oxygen. If you use 4 hydroxide ions, right, then you would have to give up 4 electrons. All right, so it's hydroxide ion to give you water, oxygen, and the 4 electrons. Once it's hydroxide ion, this is the equation. As I said, they are not going to change. But the cathode, it will be the hydrogen ion because it is below sodium in the electrochemical series.
Sir, 1 second. Oh, you know it is for hydrogen.
When you balance it, you will get 4. All right, let me just do it quickly. All right, so if the hydroxide ion will give you water and oxygen, right? Just tweak a bit better. Just this is the equation because I really can't go through it at this point. All right, I'll crunch a time. But when you balance it, this is what you're going to get. All right. So just remember it at this point. All right. So you use 4 hydroxide ion, you get 2 moles of water, oxygen, and 4 electrons. For hydrogen now, at the cathode, you have hydrogen. And remember we said positive ions, they are going to gain electrons. So if the hydrogen ion gain an electron, that will go to form hydrogen. However, hydrogen, like the halogens, it is a diatomic molecule. So it does not exist as an atom. It exists as H2. So if you have if you are producing H2, it means that there are going to be 2 hydrogen ion. 2 hydrogen ion, each of them would gain an electron, which would be a total of 2. At the cathode, you would have 2 hydrogen ions gaining 2 electrons to form your molecule of hydrogen.
Sir,
Yes.
okay, saying that the ones that are lower in the reactivity series would be the ones that are used?
That is correct.
Okay.
So it's the opposite of oxidation, whereas the one that is higher up would be displacing the next one. When it comes to electrolysis, it is the one that is further down, it is going to take part.
Sir,
right. Yes.
we're going to go through acid, base, and salts after this.
Yes.
Okay.
Yeah,
Sir, I
man,
have
so,
a question. Sir.
Yes.
Sir, sometimes on the electrolysis, them would I ask, what do you observe at the cathode? Because something gets big, smaller, and something gets larger.
All right. If it's a gas, once it's the non-metals, a gas is going to be produced. So you're going to see bubbles being produced at the anode. So for example, in this case, at the cathode, you're getting hydrogen gas. Once you produce a gas in solution, you're going to see bubbles being produced. So at the anode and the cathode, you would see bubbles being produced. All right? If you want to see it, well, don't waste time and look at it. I did an experiment on it, but just get studied. All right, so this is what would happen. For the dilute, for the electrolysis of dilute sodium chloride, you would get oxygen gas being produced at the anode because the hydroxide ion is taking part. And then at the cathode, it would be the hydrogen ion. If it was concentrated, it would still be the hydrogen ion at the cathode, but this time it would be the chloride ion. And as I said, once the chloride ion takes part, the equation is not going to change. So it would still be 2 chloride ion forming chlorine gas plus 2 electrons being given up. So for the concentrated one, it's the hydrogen ion at the cathode and chlorine gas being produced at the anode.
So, sir, what you're basically saying for the dilute, it would basically come from the dilute is what?
The hydroxide.
The hydroxide and the hydrogen, the concentration would come from the solution, the concentrated solution, and from the
All right,
one
so
go to the cathode.
Right, so hold on. When I'm talking the dilute and concentrated, it only affects the negative ion. For the positive ion, we just look at the position in the electrochemical series. So the reason why hydrogen is taking part in both instances is because we're looking at the position in the electrochemical series. So hydrogen is below sodium in the electrochemical series, hence it takes part. Just remember now, for the negative ion, once you hear dilute, just know it is the hydroxide ion. Once you hear concentrated, it's the negative ion of the salt. All right? So once you hear dilute at the anode, hydroxide ion. For the concentrated, it's the chloride ion that is going to take part. All right? So we need to move on.
Sir, what did you write after the 2, the +2 what?
Here?
No, the last thing you wrote.
Down here?
Yes.
2e for the electron. Just a second. All right, so we're going to look at the purification of copper now. All right, so you must know about the purification of copper. So in the purification of copper, the impure copper is placed at the anode. So and you place a thin piece. So let me just add it. So it's pure copper, and we are using a thin piece. All right. So I'm going to use a thin piece of pure copper metal at the cathode. And you use a solution containing copper ions as the electrolyte. Hence I'm using copper sulfate. All right. So impure copper goes to the anode, pure copper goes to the cathode. Copper sulfate solution is the electrolyte. No.
So what does it mean by impure copper?
So we're purifying copper, right?
Yeah.
Right. So it's in an impure form. So impurities are on it, but you want, let's say, clean, just copper only. Right? So just want pure copper, no impurities on it. So that is why we're saying we're purifying it. So when you set it up, right, what is going to happen? Just like any electrolysis, no, and I'm going to point it out here. This is an active electrode. Remember I said graphite? Graphite was an inert electrode because it did not take part in the reaction. What you will notice here is that this is going to break down because it is an active electrode. It is going to take part in the reaction. So this is what will happen. At the anode, your copper, this piece of copper here, it is going to be oxidized. So if it is going to be oxidized, right? So you have the copper atoms, right? So it's a metal. The piece of metal consists of metal atoms. Your metal atom, if it is going to be oxidized, it is going to give up electrons. When atoms lose electrons, they form positive ions. If the copper atom loses electrons, it is going to
Sorry,
form.
can you repeat that, please?
All right. So for the purification of copper, at the anode, your impure copper is going to be oxidized. That means the copper atoms are going to lose electrons. So the copper atoms are going to lose electrons, which means that you are going from the copper atom to the copper ions. And when this is happening, what you will notice is that the piece of copper metal, it starts to break down because the atoms that were on it, the atoms, I'm just going to put some dots, right, to represent the atoms. So the atoms that were on the metal, when they are oxidized to copper ions, they fall off. So the atoms are converted to ions. The ions fall off into the solution. And that is why the metal, you will see, start to break down because the atoms are converted into ions. So this is what is taking place at the anode in the purification of copper. The copper anode, the anode itself, is being oxidized. It's not like the case that we were looking at where the negative ion would go to the anode and get oxidized. The anode itself is getting oxidized. So the copper atom on your impure copper is being oxidized to copper ions. All right? Now remember, in electrolysis, just a second, electrons would be flowing, right? So again, positive ions would be attracted to where? The cathode. So look what happens. The positive ions, the copper 2+ ions, fall off into this solution, right? They're then attracted to the cathode. They are attracted to the cathode. When they go to the cathode, so answer your question, just give me a minute. So remember, this is what happens at the anode. It gets oxidized, so we produce Cu2 plus ions, which fall into the solution. These ions migrate to the cathode. And we already know that at the cathode, reduction is going to take place. So the copper-2 ions that migrated to the cathode, they are going to gain 2 electrons to form copper atoms. These atoms are going to attach to the cathode. And so what you will notice is that over time, in terms of an observation, you will notice the anode is getting thicker because the copper ions are being converted to atoms and sticking to it. So it is going to get thicker over time as more and more atoms are attached. And the impure copper, which is the anode, so over time, the anode is going to get thin because it is being oxidized. The atoms are converted to ions, so it is breaking down. So as an observation, the anode will get thin, the cathode will get thick, and we would have impurities falling to the bottom of the beaker. All right, so we would have impurities. All right, and in the solution, you would have had copper ions as well. So if those ions as well are moving over, the color of the solution will fade. So for observation, the anode gets thin, cathode gets thick, the impurities fall to the bottom of the beaker or the container, whichever container it is. Someone was asking a question.
Sir.
Yes.
So what about the solution? The copper solution is ion. The copper ions also from the solution I go to the pure copper.
Right. Because remember, any positive ion will be attracted to it.
Sir, follow-up question for his question, sir.
Sure.
Would it travel the same way up across, or would it go straight to the cathode? Where you put an arrow?
No, you won't use the arrow. I was just trying to let you know that when the ion come out from the anode, it will migrate over to the cathode. So I was just using the arrow to find it out. But you will not draw any on your diagram.
Sir.
Yes.
Sir, can I repeat what is taking place at the anode?
Right. So
like with the copper.
Yeah, man. So remember, if you put sodium metal in water, right, it will explode. Or if you put any metal, or if you put any reactive metal in water, or if you put metal in acids, what happens? The atom, so the metal atom is converted to the metal ion because it is being oxidized. It is the same thing that is happening to the impure copper. When you put it in the solution, it is being oxidized to copper ions. All right, so at the anode, your impure copper is being oxidized to copper ions. So this is the equation, so in the purification of copper, this is the equation for what is happening at the anode. The copper atom is oxidized, so you get copper ions plus the electrons.
So the impurities are going to the anode?
Right, because remember the impure copper is at the anode. So the impurities would be falling at the anode because the anode is impure.
The MG, where the MG from again? I can't remember.
No, ignore that. I was just explaining something.
Sir,
Yes.
but the copper 2 sulfate aid in a reaction. I know it says electrolyte, but what it reaction?
So the copper 2 ions, they are going to migrate as well, you know. Over to the cathode. So the positive ions in the solution, they are moving over to the cathode.
Sir, the impurities destroy the anode first and then it goes over to
no, it's not
what
destroyed
first.
No, man. So the anode itself, let's say this is the impure copper, right? The reaction is starting. So the copper atoms are being oxidized. So it is breaking apart. So the ions, so the copper atoms are converted into ions. So the copper ions and the impurities go in this solution. So just imagine the impurities as rust. So they just fall off to the impurities are actual solids, you know. So they just fall off to the bottom of the container. While the copper ions, they migrate over to the cathode. All right? So to sum up this, right, what you need to know, the anode is oxidized, and you must know the equation. So this is what happens at the anode, this is what happens at the cathode. Know these two equations, and notice each of them involves copper. So for the purification of copper, at the anode and the cathode, the equation just involves copper. So at the anode is oxidation, copper atom to copper ions. At the cathode is the copper ions forming copper atoms. That is it.
Sir, electro-refining and the purification of copper is the same thing?
Electro-refining? Well, I didn't see that term before, so I'm guessing it would be the same. But you must know purification of copper, all right? I want to do some calculation quickly for electrolysis.
Sir, one question.
Yeah.
You're gonna be able to go through them ask the amount of material for the electrode, amount of moles.
I think my brother. Yeah. All right, so is anybody writing anything from the board at this point?
Screenshot it, sir.
All right, yeah, so let's screenshot it and then we can, yeah, do some calculation.
You can go now.
All right.
Sir.
Yeah.
Sir, I'm always like mix up with the equation, sir. When it I gain electron and I lose electron. All the equation I'm say
all right, let's just do it one more time. In electrolysis, the ions are always on the left-hand side, whether it's positive or negative. All right, so let me do it quickly. The ions are always on the left-hand side. I'm using sodium and chlorine as the example here. So they always start out with the ions on the left-hand side. If it's a negative ion, it is going to give up the electron. All right? And so the electron must be on the right-hand side. If it's a negative ion, it is giving up the electron. So the negative ion and the electrons must be on opposite sides of the arrow. All right? For the positive ion, it is gaining electron. So the electron must be on the same side. Right? So the positive ion is gaining an electron. So it is on the same side. The negative ion is giving up the electron, so it's on opposite side. And again, we know that the chloride ion will give you Cl2. And so you need to put 2 in front, and we're going to need 2 electrons. All right? Sodium ion gain the electron from the sodium atom. That is how you get it. Understand?
Wouldn't it be 2? Wouldn't it be 2?
2N. Repeat.
2Na.
No, not 2Na. The reason why, all right, so chlorine is a diatomic molecule. That is why we have Cl2. Sodium is a metal. It exists as a metal atom, not a molecule. That is why we have Na. All right. All right, so next now the calculations. Now, the way I'm going to show you how to calculate it is different from what you will see in the book or your teacher taught you. All right? Just letting you know. You don't have to use this way. You can use it how the textbook or your teacher show you. All right? So for this, they're either going to ask you to calculate, and in most instances, they ask you to calculate the mass that is being formed. But I'm going to show you the mass and the volume of gas. Now, we know from mole concept, if you want to find the mass is equal to mole times molar mass. All right? And if you want to get the volume of gas, it is mole times RTP or STP, whichever condition is stated. All right? So mass is equal to mole times molar mass, volume of gas is mole times RTP or STP, whichever is stated. Now, in
So what stands for
electrolysis,
what RT stands for?
room temperature and pressure. All right, so for electrolysis, if you want to find moles, again, this is my way of doing it. You don't have to do it like this. So in electrolysis, a simple formula, mass Q over Q1, Q over Q1, that's the mole, and you just multiply it by molar mass, and you will get your answer. What is Q?
The
What
Q,
is Q?
explain.
All right,
Continue.
so this formula, Q, is what you would have been accustomed to, which is the current multiplied by the time. Now, Q1, you are going to multiply 96,500 coulombs times the number of electrons used. And I'm going to tell you what that is. So let us just say, right, we are looking at the electrolysis of molten magnesium chloride, right? Molten magnesium chloride. And I ask you, and I ask you to tell me the mass of magnesium that would be deposited at the cathode. All right. So Q1 is what I'm showing you first. It's 96,500 times the number of electron. Magnesium, right? If it's magnesium, magnesium is 2 plus. So if it goes to the cathode, how many electrons will it gain?
2.
2. So magnesium would need to gain 2 electrons. So how many electrons would we use?
2.
2. That is what I mean. All right. So to get your magnesium, you need to use 2 electrons. And you don't even have to write the half equation still, but once you know the charge, you know how much electron you need, right? because if it's 2 plus, there will be 2 electrons. If it's plus, it's 1 electron. 3 plus, 3 electrons. So if it was magnesium chloride, it would be 96,500 times 2, and you get 193,000. All right? Let me put a question on the board and we'll work it.
Repeat, sir.
Repeat, which part exactly?
So the magnesium multiplied by something.
No, if we're doing the electrolysis of magnesium, right? Chloride, and we want to find the mass of magnesium, you have to look at how many electrons we would use. If magnesium is 2 plus, then it would need 2 electrons, and so it would be 96,500 times 2. Because magnesium is 2 plus, so it would have to be 2 electrons. All right? But let me just put a question so we can actually apply the formula.
Excuse me, sir.
Yes, go ahead.
By what time do you think you'll upload the video, the YouTube video?
Let me see what my battery is saying. All right. It's on 27%, so I will just work until it at about 5%. All right, so let's go. So in the electrolysis,
Sir, we get a constant up on the paper.
so yes, you will get it.
Oh.
All right, so it says in the electrolysis of molten aluminum chloride, a current of 5 amperes flows for 10 minutes and 15 seconds. Calculate the mass of aluminum formed at the cathode. So, first formula, Q is equal to the current, which is I, multiplied by the time. Current is measured in amperes. So the current is 5. Now the time, it must be in seconds. So 10 minutes, so to get it in seconds, it will be 10 times 60, it should be 600, right? So 600 seconds from the 10 minutes here, plus the 15, that would be 615 seconds. So 600 plus the 15, 615 seconds. Where's my calculator? All right. So current is 5, and the time is 615.
Sorry, I get 3,075.
Right. That is correct. 3,075. Now, we said that Q1 would be 96,500 times the amount of electrons that was used. If we're interested in aluminum, what is the charge on the aluminum?
Sir, 3 plus.
3 plus.
3 plus, sir.
So if it is 3 plus, it should be 96,500 times how much?
3.
3.
Right. So because the aluminum ion is 3 plus, it will need to gain 3 electrons. So we times it by 3. So 96,500 times 3. And we get 289,500. All right, so that is Q1. So Q is equal to I times T, done. Q1 is 96,500 times 3, done. And remember, we had said what now? Mass is equal to what? Mass is moles, which is Q over Q1 times the molar mass. So Q is 3,075.
Hi, good night. I'm sorry, everyone. Sir, you lost me at 3,075. That's where you lost me. So, can you go over that part again, please?
All right, so we calculate two things, right? Q is the quantity of charge that was used in the experiment. So Q is the current multiplied by the time. The current from the question is 5 amperes. So the unit for current, so the symbol is I, the unit is amperes. So when we say I times T, it is 5 amperes, that is the current. The time, it must be in seconds. So 10 minutes, we convert it to seconds. So 10 times 60, that's 600. Plus the next 15 seconds, that's how we get the 615. So 5 times 615 gives you 3,075 coulombs. The unit for charge, for the quantity of charge, is coulomb, symbol C. Next, right, we're going to calculate Q1. Q1 is simply 96,500 times the amount of electron from our half equation. Now, we don't have to write an half equation to know how much electron is needed. Aluminum has a charge of 3+. If the charge is 3+, it must gain 3 electrons. So we know we should say 96,500 times 3, and we get 289,500. So.
Okay, thank you, sir, and thanks to everyone for the patience.
All right, so the mass.
Hold on, sir. Hold on, sir. 1 second. Where you get the 96,500?
Oh, that is a constant. Faraday's constant that we use for this type of calculation.
Sure. So I'm guessing that would be the charge for 1 electron.
Right.
Okay, sir.
So 96,500 is equal to 1 electron. So when the electron is flowing, because I don't have the time to go in all the calculation, I just have to show you the calculation, all right?
Sir, sorry to interrupt. Please, can you go over again or you get the 615, please?
Convert the minutes into seconds. So 10 times 60, that's 600. Plus another 15 seconds here, 615. So the time, it must be in seconds. But in the question, it was given in minutes. So we said 10 times 60 to convert it to seconds. And it was 10 minutes and 15 seconds, so we add the 15. All right? So we had said we are going to do Q divided by Q1. We have Q and we have Q1. Once you have Q and Q1, the calculation is basically completed. So it's 3,075. Can I erase the question or not as it?
Yes, sir, can you erase it?
All right, good. All right, so Q is 3,075 divided by 289,500 multiplied by the molar mass of aluminum, which is 27. You have a question? You can go ahead.
No, sir, I have a question.
All right, so 3,075 divided by 289,500, I get 0.01. All right, and times it now by 27. And I get 0.27 grams. All right, so look, if you want the mass, right, quick,
Sir, 1 second.
Yes, go ahead.
Where you get the 27?
That's because it's aluminum. The mass of aluminum, the mass number, 27.
Okay.
Sir, CXC brings these type of questions.
Go ahead.
Does CXC bring these types of questions?
Yes, I'm going to give you one now. So just quickly to recap, right? You're given the current and you're given the time in minutes. You are going to calculate Q, which is the current, multiplied by the time. But ensure that you convert the time into seconds. If you don't, it's wrong. So the first thing we did was convert the time into seconds. We were given minutes and seconds. So we convert the minutes to seconds. So 10 minutes is 600 seconds plus the 15 seconds. So we get 615. The current was 5. So it's 5 times 615. The question, it was asking about the mass of aluminum. So if we're doing the electrolysis, right, at the cathode, aluminum ion will be at the cathode, which is Al3+, and it will have to gain 3 electrons to form 1 mole of aluminum. So to know the quantity of charge here, Q1, we just said 96,500 times 3. So it's 96,500 times the amount of electron that is required. Once you know the charge, you know the amount of electron. So it's 96,500 times 3, and we get our answer. We call that Q1. So to get the mass, it's just Q divided by Q1.
Excuse me, sir.
Go ahead.
Where do you get the 96,500 from?
Please repeat.
Where do you get the 96,500 from?
It's a constant. Whenever we're doing this type of calculation, we have to use this constant, all right, Faraday. So you must use it, all right? So we always multiply this number by the amount of electrons, all right?
Okay, sir, thank you.
Yeah. So once you get that, it's Q divided by Q1 times the molar mass, all right?
Sir, I'm still confused.
About which part? Quickly. Which part?
Sir, all right, me read over cover question and me still don't understand where get the 60 from.
The 60?
Yes, sir.
Remember,
yeah, like yes,
the
10 times the 60, I get 600.
Right.
Add the 15, and but I still don't understand where you get the 60 from.
Because you have to
60
convert
seconds
minutes to seconds. So you convert minutes to seconds. Remember, 1 minute or 60 seconds, right?
Oh, I understand now.
From large to small, you multiply, so you can multiply.
All right, so let me find a question quickly. Just give me a second, let me look for, yes, I have one here. This is from 2014, January. All right, and it says a current of 5 amperes is passed through And for this, they gave you the constant.
Sir, what is the relative molecular mass for lead?
207.
270?
No, 207. All right, so I'm going to give you 3 minutes to try and attempt it.
So what is RAM of lead? Bottom.
207.
Yeah, but what is it?
RAM is relative atomic mass.
Relative atomic mass.
Gram, 207.
Sir. On a REM or RMM.
No, because it's an atom, it's the relative atomic mass. But it's the same number anyway you take it or any you want to interpret it. All right. All right, so as soon as you get an answer for Q, you can tell me. And when you get an answer for Q1, you'll tell me as well.
So Q is 15,000.
Sir, for Q, I got 1,500.
15,000 coulombs.
All right, let me check. Let me check as well.
1,500.
1,500.
Right, it's 1,500. And what I get for Q1?
96,500/3. The same constant you was talking about.
Question, is that 5 amperes there? 5
Right.
amperes?
Yes.
Well, I thought it was 50.
Sir, 193,000.
All right, 193,000.
So it should be one more 0.
Right. So you have Q1, and you have the mass here. So you would do
16.1.
193,000 times 207. And how much of that?
16.1.
All right, 16.
I got 1.6.
All right, let me check. So 1,500 divided by 193,000
1.6.
times 207. All right, 1.6.
Sir, question: how much electrons would lead have?
All right, so the charge on lead, so lead is 2 plus.
Oh, 2.
Right. So once you know the charge, so if it's 2 plus, it will gain 2 electrons.
Excuse me, sir, a quick question.
Yeah.
Recently I saw in a textbook that PB mean plumbed. How is that? What it mean lead right there, sir?
Please repeat.
PB means plumbate, but it
Mean
have
pl-
lead. Plumbate,
Mean-
plumbate. Or you know what I talk? Write it down. On the board.
Third, the salt related from salt.
Plumbate, PB.
Plumbate. How you spell that?
PLUMBATE.
Plumbate.
Don't remember, sir, don't remember to write the G.
So when lead oxide, we have to lead hydroxide. To get plumbate.
But the
We have
PB,
zincates too.
but PB should be just for lead. P as in the lead atom. So just remember the charge on lead is 2+. So if you don't know the charge, you wouldn't be able to do the calculation correctly, because it is the charge that allows you to know how much electrons were used to get this number correct. All right. You said you wanted to do the moles. Let me see. Just
Let's have the G.
Can just one question, what like show how you calculate like the current? The current you the particular mass.
I will have to try and make up one, but I'll make up one. But from the past papers for the
How did we get Q1?
Q1, it's 96,000. It's always this number, 96,500, multiplied by the number of electrons that are used for the half equation. So if we're looking at lead, right? Lead is Pb2+. So in the electrolysis of lead, what was it? Lead bromide, the lead would gain 2 electrons, Pb2+, gain 2 electrons to form 1 mole of lead. So we are multiplying 96,500 by the number of electrons that we use from the half equation. The reason why I didn't have to use the half equation, whatever the charge on the ion is, that's the amount of electron that would be needed. So because we know that it is Pb2+, then automatically we know that we will have to gain 2 electrons. And so we multiplied it by 2. All right. So where do you want to go? Moles or salts? I think we should do salts. But which one I prefer?
Yes, sir. Yes, sir. Oh,
Moles.
Sir, remember
sir.
Oh, but like, you can swap moles, you cannot swap.
Sir, can I talk, sir?
No.
Go ahead. Quickly.
The reason why I get the 1500 is because you the 5 times the 60
right
times the 5, you get the 1500.
That is correct.
Sir,
Yes.
I have a post paper question that is similar to that one that we do, but
Send it to my email. Send it to.
okay.
I will try to work it and upload it. All right.
Okay.
At gmail.com. All right, actually, I'm going to spend 10 minutes. I just need 10 minutes to do salts. All right, so I'm just going to spend 10 minutes on salts and then we do moles.
Yes,
so
sir.
Yes?
Yes, sir, let's do salt.
All right, so
what is that? Real chemistry AZ@gmail.com.
Real.chemist92. So real.chemist.
92.
Yeah, @gmail.com. All right, so for salts, right? The focus I'm going to do is how to prepare soluble and insoluble salts. If you don't know the solubility rules, study it. All right? If you do not know the solubility rules, study it, or else you will not know how to prepare the salts. All right? So with that said, I'm going to show you how to prepare. Right. So like all nitrates are soluble, all the halides are soluble except silver and chloride. Right. So study them.
Like all sulfates are soluble except lead sulfate.
Barium sulfate as well. And calcium sulfate is sparingly soluble.
Slightly
All right?
soluble.
So you can probably write it down, please.
There's a lot of rules, so it's better you look online or in your concise, so you can't write down all of them.
As you just Google it and press images and you just see it. All right. So I'm going to explain.
Daniel.
Mute your mic. Mute your mic.
Sorry, I'm gonna realize.
All right, if they say acid, bases, and salts, right, more than likely you will get a salt to prepare. It can be soluble or insoluble. I'm going to start off with insoluble salt. All right. Now, to get an insoluble salt, you're going to mix two soluble salts.
A question. For the
Go ahead and answer the question. I just muted everybody. The person that was asking the question, you can go ahead.
Okay, sir. I was saying that the topics that they gave us sexy, they didn't have endothermic and exothermic.
No, that is not a part of it. Neither is leach or oxidation. All right, so for example, right, let us say they ask you to prepare silver chloride. The first thing you have to know, is it soluble or is it insoluble? All right, that is why you need to study. No, this one is actually insoluble. No, so to prepare an insoluble salt, we have to mix two soluble salts. So the example of the insoluble salt is silver chloride. So based on the rules, all the group 7 elements, right? Those ions, fluoride and chloride, bromide, iodide, all of them form soluble salts, except with silver and lead. So once you say silver chloride, you know that it's an insoluble salt, all right? So since silver chloride is an insoluble salt, we are going to need to mix solutions of two salts, one with silver and one with chloride. Here's how we do it, right? You get the salt, separate them. You're asked to prepare silver chloride, separate the silver ion, right, from the chloride ion. Good? Remember we said we are going to mix what? We are going to mix two soluble salts, all right? For your positive ion, so remember salts consist of a positive ion and a negative ion. If you have a positive ion, when you combine it with a negative ion, that salt must be soluble. Your safest bet, if you forget, go with nitrate. All nitrates are soluble. So if you want a soluble salt that contains silver ions, use the nitrate ion. All right. Now, if you want a soluble salt with a positive ion, go with group 1 metals. All of the group 1 metals, as well as the ammonium ion, they form soluble salts. So just pick any metal from group 1, combine it with chloride ion, and you get a soluble salt. So for example, potassium ion with the chloride ion. All right. So the two salts that are soluble, silver nitrate, right, and potassium chloride. So each of the salt, one must contain the chloride ion, one must contain the silver ion, but they must be soluble. That is why I am using nitrate, because I know the nitrates are soluble. It doesn't matter what. And I know the potassium ion is also soluble. It doesn't matter which salt it is in. What is going to happen now is that when you mix the solution of these two salts, a double displacement reaction is going to take place. The silver ion is going to combine with the chloride ion, and the nitrate ion is going to combine with the potassium ion. So you are going to get silver chloride, which is an insoluble salt, hence I have this solid here. And you are going to get potassium nitrate. All right. And so this is how you would prepare silver chloride. Mix two soluble salts, one with silver and the next one with chloride ion. When you mix them, the silver ion will combine with the chloride ion, and you will get your silver.
Sir Millers.
You pay attention from the start?
I was listening, but I was writing at the same time.
All right, so quickly again, right? We are preparing silver chloride. To prepare silver chloride, we need two solutions, right? One containing silver, one containing chloride. But both of them must be a soluble salt. So we know that all nitrates are soluble. Good? So the silver nitrate, that would be soluble. We know that any metal from group 1 forms a soluble salt. So potassium, combining potassium ion with the chloride ion gives you a soluble salt as well. So silver nitrate and potassium chloride, the two of them are soluble salts. When you mix the two of them, what is going to happen is that the positive ions are going to trade places. So silver combined with chlorine and potassium combined with nitrate. And so you get silver chloride plus potassium nitrate. Understand?
Yes, sir.
Now this is your molecular equation. The question, it can ask you for the ionic equation as well. So let us just quickly do the ionic equation.
So let me screenshot that first for about.
Right, yeah, so the screenshot so we can move a little faster. All right?
Thanks, you can go on.
All right. So remember now, for the ionic equation, anything, you are going to break up anything in the aqueous state. So look in the equation, right? Anything that is aqueous, separate them. Silver nitrate is aqueous. That means you have silver ion plus nitrate ion, right? Don't leave off the state symbols. Potassium chloride is aqueous. So you get potassium ion and chloride ion. Silver chloride is a solid, do not break it up. Only if it is aqueous. All right? Plus potassium nitrate is aqueous. Potassium ion, nitrate ion. Once you have completed that, compare what is on the reactant side to what is on the product side. If they are in the same state, cancel them. Silver here is aqueous, but in silver chloride, it is a solid. Different state, you leave it alone. Nitrate is aqueous, aqueous. Potassium is aqueous, potassium is aqueous. The chloride ion is aqueous, but in silver chloride, it is a solid. So you write a final net ionic equation, which is silver ion.
So this is the next example of insoluble salt.
No, as in, no, I see an example, but they can ask you for the molecular equation as well as the ionic equation. This is the ionic equation. So this equation down here, where you see silver nitrate plus potassium chloride to give us silver chloride plus potassium nitrate, this is the molecular equation. But the ionic equation is just showing the ions that actually took part. So it is the silver ion because the nitrate and potassium is cancelled. With the chloride ion to give you silver chloride. All right? So that is your ionic equation. And that is the equation that you would use to represent the soluble salts. In terms of the procedure, you would mix and filter. So you mix the two soluble salts. Remember here, look, you are getting a solid and you also have a solution. So if you have an insoluble substance, so like if you have a mixture, right, a sand and salt, how you separate it? How you separate the mixture of sand and salt?
So repeat.
Filtration.
Filtration, right. So once you have an insoluble substance, I'm saying once you have an insoluble substance and you want to separate it from the solution, it's filtration. So when you want to get this insoluble salt, because remember now, you mix the two of them, right? And so the insoluble salt would still be in the solution. So to separate it, you filter it. So in terms of the technique, how you do it, you just mix the two solutions and then you filter it. The insoluble salt, that would be the residue. And you just take it out of the filter funnel and you allow it to dry.
Excuse me, sir. You can write that on the board, please.
All right, take a screenshot quickly. And so I can erase and the moles. Right,
So you just have to study the ruling.
Right. If you don't know the rules, trust me, I hit that for you. You have to know the rules.
So, sir, what about qualitative analysis?
I
did ask if we do that already.
I did that in a couple weeks ago in a class. It's posted as well. Our past papers and stuff. It's on this channel. Just check for it. All right.
What's the name of the channel?
Please repeat.
What's the name of the channel, sir?
All right. Somebody just type it again for me, please.
You mean the real chem is something?
No, that's my email.
Oh, okay.
Somebody just generate some. Just type in it. So if using this example, right? So mix solutions. All right, so all you're doing, mixing these solutions, setting up the filtration process, filter the mixture, and you just collect the residue. All right. I can just take a screenshot so we can move again. Just a second. 16%. Now, for the salts, they can ask you to do the molecular as well as the ionic equation. All right, so I'm going to erase this now.
Sorry, can I ask a question?
Sure.
Will there be
at the bottom?
I just screenshot it quickly. Go ahead with the question.
So will they be asking definitions like what's an acid? They can ask that. What's an acid?
Yes, right, they can ask. I remember an acidic salt is one that has hydrogen in it, all right?
Yes, sir, but I don't know what's a strong acid and a weak acid.
Strong acid dissociate or ionize completely. Weak acid partially ionized.
Oh,
so, right, yeah. And remember, any carboxylic acid is a weak acid.
Okay.
So can you repeat that, please?
So strong acid fully ionized in solution, weak acid partially ionized.
What did you say for the example?
Any carboxylic acid, so methanoic acid, ethanoic acid, any of those carboxylic acid is a weak acid. And so weak acids are weak electrolytes as well for that reason. And strong acids are strong electrolytes. All right, if you want a soluble salt, you will do an acid-base reaction. So for example, copper sulfate, if you want to prepare copper sulfate, you can react copper oxide with sulfuric acid, and you will get copper sulfate and water. All right? So if you want a soluble salt, it is simply an acid-base reaction. The positive ion of this, it is coming from the base.
Sir.
All right? Just a second. The positive ion of the salt, it comes from the base, and the negative ion, it comes from the acid. So if you want to prepare copper sulfate, the copper is coming from the base. Base is the oxide of a metal. That is why we can use copper oxide. You can use copper hydroxide as well. Any base. The acid that contains the sulfate ion is sulfuric acid. Go ahead with the question.
So I was saying that if them ask us to prepare a soluble salt, we can go to the basic like sodium hydroxide and hydrochloric acid.
If so, for sodium hydroxide and hydrochloric acid, which salt, so if you have sodium hydroxide and hydrochloric acid, which salt would you have been preparing?
Sodium chloride.
Right. And if you check again, the positive ion of the salt is coming from the base, the negative ion is coming from the acid. All right. So
yes.
if you get a soluble salt, it's just an acid-base reaction. However, you will not do filtration, all right? So you will still mix the acid and the base, right? So the acid and the base, you will mix it. But because the salt is soluble, so let's say in this case, right, the copper oxide and the sulfuric acid, we would add the copper oxide in excess. That means you would add enough copper oxide until no more dissolves. All right. So you mix, then you filter. All right. So you will still perform filtration. All right. But this time, the residue is not your salt. The filtrate is the salt. All right. So the filtrate is copper sulfate. All right. So you mix, so you add the base in excess. So once you mix them, right? You filter, but this time the filtrate is a salt. So to get this soluble salt, you have to perform a third step, which is crystallization. So you mix, you filter, and then you perform crystallization, which is simply heating this solution. All right, so you mix, filter, perform crystallization. There's actually a past paper on this, yeah. So you mix, filter, crystallization. That's the actual procedure. In terms of the equation, this is what you would have done. All right. Before the battery goes any further, let us do some more concept. But let us make this actually be helpful. How do you prepare soluble salt? Just Google solubility rules and study them. All right. If you see that you get an insoluble salt to prepare, just separate the two ions. All right. The positive one, combine it with nitrate. Just combine it with nitrate ion and you're good. The negative ion, combine it with potassium ion, or a next ion from group 1. And you put those two in the equation.
So we are expensive.
Just recapping the insoluble salt.
So we are explain.
The
insoluble
salt.
salt.
Just recapping. So if you get the insoluble salt, separate the two ions. The positive one, combine it with nitrate. The negative one, choose a metal from group 1. And those goes into your equation. Good? So if you are to
what insoluble, sir?
All right, so quickly, an example, if you are using, let's say, lead iodide. Good? Lead iodide, separate the lead ion and the iodide ion. Lead nitrate, potassium iodide. You see that? Yeah. Combine nitrate with the positive ion and the group 1 metal with the negative ion. So lead nitrate, potassium iodide. If you put that in the equation, the lead ion will combine with the iodide ion, the potassium combined with nitrate. And you get the insoluble salt. That's it. All right?
So you understand, sir?
All right.
For the insoluble one, you just, what you say is, yeah, go use it to some of the.
Look, you're asked to prepare PbI2. This is an insoluble salt, right? Separate the two of them. Pb separated from I. Because you're going to have to mix 2 salts in order to get this product here. So they are asking you to show a reaction to prepare this. So I'm telling you, separate the 2 of them. Separate the lead and the iodine. Combine nitrate with the positive ion. Lead is the positive ion. And I'm saying pick a metal from group 1 to use with the negative ion.
Potassium, sir. Potassium, sir.
Right. So I'm saying you will have potassium iodide and lead nitrate. So once it's an insoluble salt, just separate the 2 ions. Then you put nitrate with the positive one and potassium with the negative one. That is your reaction. Lead nitrate plus potassium iodide. What you're going to do is just switch the places with the potassium and the lead. And so what you would have gotten as the product of this, you would have gotten lead iodide which is your insoluble plus potassium nitrate. And that's it. Understand? Not sure if it works.
Sir.
Yeah.
Yes, sir. I understand.
Moles. All right, let's try some moles. Okay.
Excuse me, sir. After do the moles, then that's it for the night.
When Butcher dead, I'm going to charge it up. If I'm still awake, I will just come back on here. So if you want to check back around 12, if I'm here, we can practice.
So exam tomorrow.
No, I'm just saying, if anybody is here and want to work.
Yes, sir, I want to continue, please.
So I know somebody that teacher like you for my school, sir. But a teacher like you at my school. Many teacher like you at my school.
So sir, can I go and watch the qualitative videos and then check back around that time?
Yeah, just check back around for it.
Okay, thank you.
Yeah, ma'am.
Send the questions to your email.
What time we're going to? 1.
No, as in, no, my battery load is up on 14% now. So my
put it on chat, sir.
No,
I can't put it on charge no one
no,
while you're at it.
No, we're setting on the charger, as in, no, plug on the ear, so.
But Jesus.
Where I have it set up. All right, so let's go again. All
I
right.
was saying I sent you the email.
Yeah, I'm going to check it after. I want to check it after. All right, so the mole concept, right? And now I teach it kind of different from most people, all right? So with the mole concept, you're going to do 2 things, and it's really kind of simple. You're either going to divide or multiply in the mole concept. Good? The only time you would divide is when you're finding moles. If you're not finding moles, do not divide. All right? I soon won't tell you what to, but just know if you're asked to find the number of moles, divide. If you're finding anything else, multiply. So if you're finding mole, you will either be given mass, in which you will divide by molar mass. You are going to be given the number of particles. In that case, you will divide by Avogadro's number. Or you would be given the volume of gas. And if you are given RTP, it's 24 dm³. And if it's STP, it's 22.4 dm³. All right? So if you're asked
Yeah, what that's I know the formula them, but like feed denominator them. Oh yeah.
These are
amount
all
of substance.
right. These are all constants. So the denominator, they are all constants.
So what is number of P?
Please repeat.
Number of P.
The number of particles.
Oh.
Right. So for particles, we use Avogadro's number. All right. But in the question, if you get a covalent compound, it will not say particles. All right. So you can see atoms.
We say molecules.
And you can see molecules. If it's a covalent compound, it will say molecule. All right. But if you see atoms are molecules, just know it is particles. So you must use Avogadro's number. So if you're asked to find moles, at no point you should be multiplying. All right? So if you want to find mole, you divide. If you are given mass, the only thing that goes with mass is molar mass. So you cannot get mass and be using Avogadro's number. Don't work. You cannot get mass and be using 24 dm³. The units must.
Excuse me, sir.
Yes.
24 dm³, that's a RTP, right?
Yeah, man, RTP. And 24.
Sir, on the exam, they're going to give you the units, right?
Yes. So if it's RTP, is 24 dm cube. Or you can use 24,000 cm cube. So you can write it in dm cube or cm cube. All right? Now, if you're not finding moles, so remember I said if you're finding moles, you divide, right? But if you're not finding moles, you will be finding mass. You will be finding the number of particles. You will be finding the volume of gas. So quickly, if you're finding moles, you will always be dividing, right? The constant is always the denominator. Remember that. The constant is always the denominator. So if you're finding mole, you divide whatever you're given by its constant. Now, if you're not being asked for mole, you will be asked for mass. In which case, it will be mole times molar mass. If it's for particles, it will be mole times Avogadro's number. And if it's volume of gas, it's mole times RTP or STP. So that for titration, that comes under volumetric analysis, and it wasn't listed. So mole concept is not volumetric analysis, but we can do one just if you want to be on the safe side. All right. So let me actually work some questions.
Sir?
Yes?
Sir, can you work the type of questions where then will give us a specific atom with the grams, and then that was to find the volume, that type of conversion that confused me.
Right. It's no problem. You see, for that part, just remember these two here. If you're finding moles, it must always be dividing. And if you look at the formula, right, if you're not finding mole, they're going to ask you for one of these at the top. So finding mass, it goes with molar mass. Finding particles, Avogadro's number. Anything to do with volume of gas, RTP or STP. All right?
Sir,
Yes?
volumetric analysis come under acid, bases, and salts, so you still mean that we're not getting it?
But it's actually, it's listed as a separate topic. Let me check if it's as a separate heading. But I'm going to do it still to make sure, all right? We're not going to leave it.
No, sir, me right.
I think the text screenshot already, all right. Give me a second.
No, I'm doing it on my laptop. So.
All right, so mole is volume of gas. So if you're given volume of gas,
Sir.
Yes?
So you only see them at the family at the top and the second family. Never see the third one.
I said the 24 dm cube already in my class.
I say if it's RTP, if they tell RTP, they use 24 dm cube. And if they tell you STP, they use 22.4 dm cube.
Sir, so based on what you put on the board, that means that the conversion, for example, if it was grams to volume, it would be grams to moles, then moles to volume?
Right. Simple as that. So you would use this. So you would use this formula, mass over molar mass. Once you get the mole, you just times it by the RTP, and you have the volume of gas. Right. All right. So I think there was one on the 2018 paper. Let me check. I think I saw one. Not 2018, 2021, January. Let me check quickly. All right, so yes, I have one here. So I'm going to Erase now. And this question is for 2 marks. 2 marks. All right, so first, it says calculate the number of moles of atoms in 80 grams of calcium. So, calculate the number of moles of atoms in 80 grams of calcium. All right, so we have 80 grams of calcium.
So that's the mass, right? The 80 grams.
Please repeat? Yes, the mass is 80 grams.
Okay.
This question will number of moles. Oh, no, let me see if I write it good. If it want moles are atoms. Calculate the number of atoms. Oh, I know that is all right. It's calculate the number of atoms. Right, so they want the number of atoms, right? And if they're asking for atoms, well, they already given it in, right? For atoms, which constant do we use when it's dealing with atoms?
Avogadro's number.
Avocado.
So to get the number of atoms, are we going to divide or multiply?
Multiply.
So multiply.
Because the only time we divide is if we're
When I said moles.
right? No, based on our equations, right? We only have constant, the atoms, and the moles.
What?
Is it?
You say the only time you divide is what?
Right, so in our...
We are finding moles. Yeah.
In the equations I just gave, right? We would have mole, the number of particles, and the constant. All right? So if you're finding the number of atoms, and once you're finding the number of atoms, we must multiply. Only 2 things remains from the equation, the mole and the constant. So if you want the number of atoms, you must be multiplying the mole and the constant. So it is the mole times Avogadro's number, 6.0 times 10 to the 23rd power. But the question is, did the question give us the number of moles?
No, sir.
What did it give us?
The grams.
The relative atomic mass.
No, not that. This.
Oh, the mass.
Right. It asks us to calculate the number of atoms in 80 grams of calcium. Right. So to get the number of atoms, we need the moles. So the question is, can we get moles from mass?
Yes, sir.
All right. So how do we get moles from mass. Mole is equal to
Divide.
Mass.
Divided by mm.
right, so it's 80 divided by 40, and we will get 2. So now that we have the number of moles, we can go ahead and do our calculation. And I think this should be 12 times 10, 23.
So how you get the 12?
It's not 12, it's 1.2. It's
1.2.
Yeah.
So 25.
24.
I get 25, I don't know.
You get 25, try it again.
Sir, 25 get 2.
Yes,
sir.
25, sir.
All right, let me try it again. You press exponent.
Yeah, exponent 23.
So you press 6, expo 23.
6, I put 6.0 times 10 expo 23.
No. Don't press times 10. Press 6. So I'm going to press 6. The EXP button, 23. So press 6.
Oh, I see it now, 24.
Right. So do not press times 10 and EXP. Just 6, the EXP button, then 23.
Oh, so that we should do for everything?
Yeah.
Whenever you see times 10, you just press the exponential button.
Sir?
Yes?
Couldn't you also work this out in a ratio? And cross-multiply? As in, for example...
Oh, sure. Yeah, if you want to. So there's no, remember, there's no one set way of working moles. All right, so if you have a method that works for you, you can use it.
Okay.
Good night, sir. Should we bring a scientific calculator to the exams?
Definitely.
Okay, I was just being sure.
Yeah. All right, so this is how we would arrive at our answer. But there's a next small question. It's a little more challenging.
Sir,
yes,
while they're doing that, we get a periodic table and paper too.
Yeah, I know they get it for Q. I'm not sure if they give you a periodic table for CSEC.
No, we don't. Nope, we don't.
Never.
All right, just a second. There's a moles question that I want to work. Well, I know how it's phrased. All right, if you get this type of moles, this one is more straightforward, right?
So I get 1.2.
2 times 6 times, way of times 10. What did you press on your calculator?
Pardon me, sir?
We multiply 2 times 6 times 10 to the 23.
Sir, I'm asking a question, sir. Or you put on the 10 to the 20 to the power of 23, sir?
What kind of calculator you have? What's the brand?
Sir, I don't have any calculator.
We can't tell you then. All right.
Sir, I have Casio, but the EXP don't depend it.
If you
Sir, I have a sir.
Yes.
Where I'm at now, my calculator is not where I'm at, so it will be
Alright,
tomorrow morning. But it's one like that though.
Right, just look at the base. If you look at the base, right, if you don't see EXP, you might have a button that says 10 with an X. So if you don't see EXP, you will have a button with
use blank.
It's blank. Normally, I normally have an exponential button on it. I'm not sure what to tell you. All right. But yeah, I'm going to show you the next type of question. But so this one is the easier one, right? You have one next one where you get.
Sir.
Yes.
Yeah, you put down 1.2 times 10 to the power of 24.
Right, this is the answer.
Oh,
So-
add that answer I get from the calculator?
Right.
Okay.
So 2 times this give us this as the answer. And when you're doing this type of calculation, ensure you pay attention and write this number as well, and not just 1.2.
Oh, okay, sir.
Okay, so next question.
Yeah. Just a second, let me check. Listen, so we have more time. All right, so I'm just going to write the equations so we can move fast. So when calcium carbonate decomposes, we get calcium oxide and CO2. All right. So what I'm going to do, I'm going to give you a mass of calcium carbonate and ask you for the volume of CO2. All right, so what volume of carbon dioxide will be produced when 5 grams of calcium carbonate decomposes? So this question, right? So when you get a question like this, first look at what it is asking you for. So it says what volume of CO2, what volume of CO2. So that means it wants the volume. So, and it is at RTP, so we know that volume is equal to mole times RTP, which is 24 dm cubed. And we want the volume of CO2. But in the question, what information? But however, the only thing
5 grams.
But 5 grams of what?
Calcium.
Calcium.
Calcium carbonate. All right, not CO2. But so the next thing we're going to do, whatever information they give us, we're going to calculate moles. So 5 grams of calcium carbonate, we're going to calculate the mole of calcium carbonate. So that would be 5. The molar mass of calcium carbonate is 100. All right.
100?
Yeah. Calcium is 40, carbon is 12, and 3 oxygen 16, 32, 48.
So, sir, wouldn't that be in the question though? Like they put the 100?
They can put the 100, or they can give you the individual masses and you work it out. Yeah.
Okay.
5 divided by 100, what's that? 0.05?
So that's 0.05.
Right. So 0.05 moles. So this is the mole of calcium carbonate, but what we need is the mole of CO2. So to get the mole of CO2, you have to use the balance equation. You're supposed to be familiar with mole ratio, right?
Yes, sir.
Right. So based on this balance equation, we have 1 mole of calcium carbonate.
Sir, is this going to be the last topic?
Yeah. And then our time now.
11 o'clock, sir. But we can go through qualitative analysis, sir.
Sir, it's still early.
What's the video?
Exactly.
There's the video with the qualitative analysis and past paper already. I'm going to do this. Yes, just check the playlist or something. I don't remember where it is, but just check them. It's there. As I said, I'm going to break, charge up the phone, come back around 12 if anybody is here. I practice.
Yes, sir, I'm here. I'm here.
Why can't we come back at 3?
Sir, how do we get access to
What
the
that
link?
person had just said? 3?
All right. Focus. Ready? Come. So we have the mole of calcium carbonate, but we need the mole of CO2. So you are going to come to the equation, right? Look at the mole ratio between calcium carbonate and CO2. It's a 1-to-1 mole ratio. Because it's a 1-to-1 mole ratio, the same mole of calcium carbonate that decomposes will give you the same mole of CO2. So the next part now, what is the mole of CO2? The mole of CO2 is equal to 0.05. Why is it 0.05?
Sir, how you know there's a 1-to-1 mole ratio?
So you look at when you look at the equation, the numbers in front tell you the moles. If you don't see any number, it's 1. So it's 1 mole of calcium carbonate, 1 mole of CO2.
Sir, will the equations always be balanced?
Please repeat.
Will the equations always be balanced, or would they possibly ask us to balance it?
Sometimes you will have to balance it. All right? But you will never see a 1 in the equation. All right? Only 2 or more. So because it's a 1-to-1 mole ratio, the same amount of moles of calcium carbonate is the same amount of moles of
Sir, question. For calcium, wouldn't the RAM be 20?
For calcium, no, the atomic number is 20 for calcium. The mass is 40.
Sir, did they give you the mass?
Yes, they will give you the mass number. All right. So the mole of calcium carbonate is 0.05.
So, sir, isn't carbon's at atomic number 12?
That is correct, 12.
And then the oxygen would be 16 times the 3.
Right.
So, sir, isn't there 1 calcium there?
What are you getting at? So calcium is 40, carbon is 12, 3 oxygen is 48. When you add them up, they get 100. They don't get to 100. All right.
All right, sir, continue.
Yeah, man. So we see how we get the mole of CO2 to be 0.05, right?
Yes, sir.
Right. So remember, all along, all we needed to complete the calculation from step 1 was the mole of CO2. So now that we have the mole of CO2, we can go ahead and complete step 1. So the volume of CO2 is 0.05 times 24. All right, and we would get 1.2. Once you get an equation, or once a reaction occurs, you must use the equation. All right, you must use mole ratio.
Sir, question like these we're getting on CXC?
For mole concept, it can come like this. Well, it should come like this, or where they just ask you to find
What
moles
is it?
or mass. All right, let me see if we find the one from this.
Sir, you can do one where them ask for the molar concentration.
That is titration.
Oh, that now?
Yeah.
So I can want to ask for the mass. You never did the one with the mass.
Give me a second, I'm see if I find it. I think it was 2014. Just a second.
Sir, come back 12 o'clock, sir.
All right.
Need some rest, man.
Oh, this 5%. No, milk food. We did have a participle on it. Oh, see it here. Yes, we find it. All right, the phone is on 5%. If it, let us see if we can do it quickly. And then. Right.
And then come back, sir?
I'm going to come back. What time now? Not once we break for an hour.
It's
My phone
11:07.
My phone are dead too.
11:07 now.
All right, when whatever time we break for an hour. So charge about your phone.
Okay.
All right, so this question, it says, all right, I'm just going to put the equation on the board. So calcium nitrate. All right, so quickly, just take a screenshot of the question. All right, so this is the equation, right, for the decomposition of calcium nitrate. So it says this, if 5 grams of calcium nitrate decomposes, calculate the volume of NO2. So as I said, they're asking for volume of NO2. So we know that volume is equal to mole times RTP, so it's 24 BMQ. However, what did they give us in the question?
The mass, 5 grams.
12 grams of
The mass.
Sir, for the question here, it's supposed to be nitrogen times 2, right? And oxygen times 6. So?
Yes, for this, yes. All right, so to get the molar mass of calcium nitrate, so this is the formula CaNO3 bracket 2. So you have 1 calcium, so that's 1 times 40. 1 oxygen inside the bracket, and 2 outside. 1 times 2, that is 2, and the mass is 14. 3 times 2, 6 times the mass, which is 16. All right, so 6 times 16 plus 28 plus 40, 164. All right, so to get the mole of calcium nitrate, wait, it's here, calcium nitrate, it would be 5 grams divided by 164 gram per mole. So
0.03.
0.03, all right, good. Now, what is the mole ratio between calcium nitrate and NO2?
2 to 4.
Which is the same as
1 to 2.
Right. So to get the mole of NO2, how would we get the mole of NO2? It would be the mole
of the 0.03.
Yeah, times what? Times what?
Times
24. Right. Because the amount
Wait,
of mole.
sir.
Yes?
I get the 2.
So isn't it 24?
Oh, the 2, okay.
It's 1 to 2 mole ratio between
Okay, yes,
calcium
sir.
and magnesium. So I'm going to get 0.06. And then once you have the mole, you just times it by RTP. So the volume is equal to 0.06 times 24.
So that's 1.44.
Right.
Sir, oh, you got the 40 for the calcium, the 1 times the 40.
The mass of calcium is 40. Oh. So calcium, the atomic mass for calcium is 40. I have 1 atom of calcium. So that's 1 times 40. The nitrogen is inside of the bracket, the 2 is outside. So it's the number of atoms inside the bracket times the number outside. So 2 times 1, that's 2 atoms of nitrogen times the mass of nitrogen. All right? And the same for oxygen, 3, 2, 16. Please take a screenshot because this, what is this? 4%, all right. Good. All right, so, all right, so just take a screenshot and we charge up phone and come back 1 hour from now, which is 12:15. All right, let me stop the recording at this point.
Sir, it's the same link?
Yeah, man, same link.
Can you upload this recording now?
Yes, I'm going to do it now.